Welcome everyone to day 3 of the Pistachio short course. I am going to go over some of the logistics before we dive into today's event. On the screen right now, you'll see our agenda. We have a few breaks built in between our speakers. So we're looking forward to an exciting day. As a reminder, if you have questions for speakers, please type them into the Q&A, which at the bottom you can see in your Zoom ribbon bar, the Q&A box, and you type it there. As a reminder, since we have several speakers, please put the speaker's name before the question. So if you want to direct a question to Louise, you would put Louise and then type the question so we know exactly who the question is for. Do not put any questions into the chat because they may be missed. Chat is for comments. If you want to say hi to someone, and make sure you do the drop down all panelists and attendees so that everyone can see your conversation that's in the chat. For continuing education units today, we have 2.5 hours of other for California Department of Pesticide Regulations. That's for your private applicators, your PCAs, that stuff. In order to get that credit, you must answer the poll pop-up questions that happen during the event. And then we'll send you a quiz that you have to take. You want to pay attention to those poll questions, as the poll questions will be the questions that are on the quiz. You have to pass the quiz by 70%, and then we'll send you your verifications. We also have certified crop advisor credit. That's the same as we've had the past couple days, where we'll have a QR code displayed at the end of the meeting where you can scan with your phone. Also, we will be able to add you in if you don't have that app. You just need to send us an email to ANR program support. With that, I'm going to direct it over to Phoebe, who is going to introduce our first speaker for the day.
Good morning, everyone. Welcome to day 3 of the short course. So our first speaker for the morning is Louise Ferguson, who is the specialist for pistachios and other subtropical plants at UC Davis. And she's going to be going over pistachio canopy management and its effect on yield components.
Okay, shall I start my screen?
Yes.
Okay. Okay. Morning, everybody. I'm going to be discussing canopy management today. Can everybody hear me? Oh, excuse me. Good. Canopy management today. I'd first like to say that this presentation was developed in complete cooperation with Farm Advisor Emeritus Robert H. Beatty and Carlo Finucchi, who I believe his grandson Dominic is in the audience today. So I'd like to first bring up my laser pointer here. Okay, and start. We're going to cover canopy management today. We're going to go through exactly what it is. We're going to spend quite a bit of time on why you do it, then when you do it, then how and who does it. We're going to cover both hand and mechanical canopy management, mechanical pruning, and we're going to cover the economics of hand and mechanical pruning. And I'm putting this tree here just to show you that if you don't prune your canopy, this is what you're going to get. Something that you cannot harvest, and my pointer doesn't seem to be working very well. Okay. So start with a definition. What is canopy management? Canopy management is pruning a mature tree starting at about 6 to 8 years through the lifespan of the tree. Basically, like any management, it is identifying problems and making decisions to achieve the desired result. That means height. We're going to be looking at the height of the canopy, the volume that you want the canopy to apply, the accessibility of the trunk, because you're going to be mechanically harvesting. We're going to be looking at branch and shoot orientation, light penetration and interception, and then of course, net profit. Excuse me. I'm going to go back one, net profit. I basically don't want to hear how much yield you had. What I want to hear is how many dollars you took out per square foot of orchard floor. Our whole objective here is to get what that man is holding in his hand, this, over to this. Harvestable yield is what we're really concerned about, quality harvestable yield. Okay, so why do canopy management? Why prune a mature tree? I'm sorry, these things are moving a little faster. Why prune a mature tree? Primarily for orchard operations, for spraying, for harvesting. You have to penetrate that canopy. You want to ensure good annual crops, and that means light interception. That means covering your orchard floor with tree canopy. We're looking for approximately 80% of the orchard floor to be covered with tree canopy when you look down at noon. This is, you wouldn't basically design a factory of 2,000 square feet and put one little processing line in 100 square feet. You want to utilize that entire floor. You also want light penetration into the canopy. As Dr. Gordon explained to you in her talk, basically the leaves are the workers of the tree with photosynthesis. If they don't get light, they don't photosynthesize. You want to, in this very apically dominant species, you want to increase the branching because that means more bearing points, more buds. And you want to have, I'm sorry about this, I better keep my finger away from my mouse. You want to have even annual yields, better alternate bearing. So here, why prune a mature tree? As I said, orchard operations, spraying, and harvesting. About 10 years ago, we did some harvesting research. We called it the Harvest Rodeo. We tested all the harvesters that we had at that point in time on the biggest and oldest trees we could find. I think these trees now must be approximately, close to 45 years old down in Kern County. It doesn't take somebody who's skilled in geometry to see that some of these nuts are not going to make it into that catch frame when force is applied to this trunk. Basically, the major reason for pruning a canopy is to get your yield into that catch frame. What we know about trunk shaking is that it transmits force very well vertically. As you start to get angles, it transmits less well, transmits moderately poorly this way and very poorly in a down and hanging direction. So we want to prune our canopy to maximize the shake. And especially something like this, basically if it starts doing this on these low hanging branches, there's often a good chance the fruit will not come off, even if it's ripe. I'm going to demonstrate why. Here we have on this horizontal axis, this is data from 2010, developed with Dr. Uriel Rosa in the Department of Agricultural Engineering at UC Davis. He has now been replaced by Dr. Riza Assani, who's at UC Merced and will be continuing mechanical harvesting research. What we have here on the horizontal axis is time. We put down white frames below the tree and we trained high-speed cameras on them and indicated what percentage of the frame was covered by nuts in time. For the first 1 or 2 seconds, nothing really happened. And then within seconds, about 2 to 7, you could see that 80% of that frame was demonstrated. The point I'm making here is that with tree shaking, it should almost be called not shaking, but jolting the fruit off the tree. It's what I've learned doing mechanical harvesting research. If it doesn't come off quickly, it's not going to come off. So you want to maximize your tree shape to make that happen. Okay. So the canopy structure, when you're going to be seeing this picture a lot, we want for harvest is a tree that is compact and upright, has an accessible trunk, has scaffolds that are upright, short, and as short as possible for good volume, and stiff. You want the canopy thinned, meaning the branches don't damp one another in harvesting. Oof. And right now I'm going to say that I'm not going to discuss circle tying in this presentation because one, we don't really have any data about how circle time affects mechanical harvesting. I will say that it appears to make the trees more upright, but we really have no data to analyze circle time, okay? Again, another reason why prune a mature tree, we want to ensure good annual crops. And that means two aspects of light. That means light interception. That means covering that orchard floor with canopy up to about 80%. And it means penetration or infiltration of the light through the canopy. This is a picture I took on November 3rd up in Colusa County, 9-year-old orchard. And basically, this was taken at almost noon. And what you can see is these trees haven't fully expanded all their space, but it appears here that a good 70 and approach 80% of the orchard floor at noon is covered. This basically is accepted as good orchard floor, efficient orchard floor management, meaning canopy management rather. I also want you to notice the dappled quality of this light. Basically, this indicates that light is penetrating the canopy and is intercepted by the lower leaves lower in the canopy. Okay, that's what you want to see. This is what you don't want to see. Darkness at noon down under the canopy. If you have that, what you're going to have is a lot of this poor, bare shoot growth with perhaps some fruit production, but it will look like this. Very short shoot growth. By the end of the season, the leaves depleted, and these nuts, this was just taken last week, these nuts are probably not filled. So this is the reason we want to prune, to increase light infiltration into the canopy. Again, why prune a mature tree? For both branching, more leaves to photosynthesize, more bearing points and buds to increase, as Phoebe demonstrated to you in her first presentation in this course. The more buds you have, the more clusters you have, the more nuts. And if you have a better leaf to cluster ratio, you can hit that 18 to 21 nuts per ounce. This is the kind of tree we're looking for again by spring. This is Golden Hills on UCB1. What we basically have here is a clear trunk for harvesting, nice uprights, and a tree that's occupying its space in the orchard with multiple clusters, and the scaffolds are occupying their place within the canopy. Okay. Another reason for why prune a mature tree is, as Phoebe explained to us in the very first lecture, pistachios have alternate bearing. Basically, the mechanism of alternate bearing, just to review briefly, is back here on the 1-year-old leafless wood is the crop for this year. Basically, this crop was set, and initially the pericarp expanded with the carbohydrates, as Dr. Zwinicki's research is showing us in his carbohydrate observatory, are supported by the carbohydrates stored back here. Out here, we have the shoot growth for this coming year with the buds in these axils for next year's crop and the vegetative growth here. What happens as this crop basically matures, these buds, depending upon the amount of crop load and demand on the resources that these leaves are producing, begin to upsize. We don't really know the mechanism, but the final mechanism, but we do have some evidence. What do you do about alternate bearing? Thus far, the only data we have for controlling alternate bearing, after trying many other approaches, is that mechanical topping mitigates alternate bearing. It's more effective than hedging, and it was most effective prior to the low crop year. This data was developed from 1989 through 1995. It was on a Kerman scion on an Atlantica rootstock. Okay. Basically, this is what we did in that experiment. We did a severe mechanical topping separately, a severe mechanical hedging separately, and we did the two combined, and a control treatment. Basically, what we found was that severe mechanical topping and hedging, back then it was into 2 or 3 year old wood. These were trees down in Kern County, right at the junction of 46 and 33, then called the Blackwell Land Ranch, that had reached an alternate bearing index of approximately 81, which means that they were varying from as much as low as 200 or 300 pounds per acre to up to over 3,000. What we found was the severe mechanical topping particularly stimulated strong vegetative growth that produced a better ratio of bearing to non-bearing shoots. We did not defeat that within shoot mechanism of bud drop. What we did was just produce a better mixture, a better ratio of bearing to non-bearing shoots. So Bob Beatty and I had a friendly argument about topping and hedging going into, oh, excuse me, I forgot to mention that we found, and the key point, we found that it was more effective doing it before the off-crop year. So basically, we were making a lower crop lower. So by topping and hedging going into the off-crop year. So Bob Beatty and I had a friendly argument going for about, I'd say, a good 10 years about that just doesn't make sense. Making a lower crop lower. Why should that help the tree? So basically, we had this rootstock trial at Kearney that we had put in 1989. At that time, we had 4 seedling rootstocks: the Atlantica, this tree, the Pioneer Gold 1 or Integrarima. Both of these are species, meaning they are not a hybrid. We had the Pioneer, sorry, my mouse is very sensitive. We had the Pioneer Gold 2, which was this mother, an Integrarima mother, an Atlantica pollinating parent, and we had UCB1, which was the Atlantica mother tree and the Integrarima male tree, a pollinating tree. I want you to first look at the differences in growth on these 3 trees. Basically, what the Integrarima parentage seems to bring to any rootstock that has Integrarima in it is successive flushes of shoot growth. There's the first flush of shoot growth that's in the bud and formed the previous year, called preformed, which means it has gone through it's gone through the chill of the previous winter. And then there are successive flushes of shoot growth, and I'm trying to orient my pointer here, successive flushes of shoot growth that are what's called neoformed. They were generated in the year during the season, did not experience chilling. So Bob set out to demonstrate that, well, basically to investigate why pruning going into an off-crop year was more effective at mitigating alternate bearing, because lowering a low crop would seem to exacerbate alternate bearing. So he repeated the earlier trial with topping and hedging entering the on year and topping and hedging entering the off year. In this trial, we had all 4 rootstocks at 10 replications per block, and we had 10 blocks. Now I'm going to walk you through the results. Okay, over here, we have the rootstock. Atlantica, a species. Integrarima, a species, not a hybrid. Here we have, and these, bear in mind, we're all seedling rootstocks. Here we have the Integrarima. I'm sorry about this. I better stay away from the mouse. Here we have the Integrarima and the Atlantica, which is PG2, we called it then. Again, it was a seedling. It's not platinum. Platinum is a selection of this, as Elizabeth explained to you. And down here, we have the UCB1. Again, these were all seedling rootstocks, field run. Basically, over the 6-year trial, they were topped and hedged before the on year. the off year, the on year, the off year, on year, off year, on year, off year. These are the results of the alternate bearing. In terms for the Atlantica rootstock, basically the data came in consistent with the 1995 data. If we pruned before the on year, the alternate bearing index was 0.79. Pruning before the off year whacked it back about by half to 0.41. With the Integra rootstock, pruning before the on year, alternate bearing index about 0.55, so less than the Atlantica rootstock. Pruning before the off year knocked it back by more than half. But the really interesting data came in on the hybrids. First of all, it appeared, sorry about this, it appeared that the alternate bearing index was no different whether you prune before the on or the off year for both the Integra Atlantic hybrid and the Atlantic Integra hybrid, both for the PG1 and the UCB1. So what this means is that there is something, looking at the data from the Integra rootstock on down, there's something about the vigor imparted by this rootstock that interacts with the mechanical pruning to produce less or no effect on the alternate bearing. I'd also like to show you the yield in this block. This is Bob Beatty's block. He was the one that conducted this experiment. The Atlantica rootstock over 6 years averaged about 3,800 pounds to the acre, but this is the effect of pruning before the on and off year and average annual yields. The Integra rootstock came across as about 4,700 pounds to the acre, average over the 6 years, and about a 400-pound advantage for pruning prior to the off year. For the hybrids, there was virtually no difference in the yield on the PG2 hybrid, but there was an advantage for the pruning before the off year, just slightly for the UCB1 rootstock. These were trees that I said now are over 30 years old, and they were all on seedling rootstocks. So the conclusions and implications here is one, the 1995 and the 2018 data are consistent for trees on the Atlantica seedlings. The major implication is that the 2018 data demonstrated that there is an interaction between rootstock vigor and mechanical pruning that affected alternate bearing. Again, remember, all these rootstocks were seedling rootstocks. The cloned rootstocks now are specific selections. This was overall, so this was from a range of trees, not from a specific rootstock from a specific nursery, okay? So canopy management, when do you start it? You start it at about 6 to 8 years. This is a tree entering the 6th year. So at the end of this year, it will be considered pruning as opposed to canopy management, as opposed to training. I'd like to call your attention to one thing in this picture before we move on. You notice the trees in the background are fully leafed out. Some of them are, some of them aren't. These were trees that suffered from juvenile winter tree dieback back in 2012 and 13. Basically, what I'd like to demonstrate is that you often think sudden cold affects only the very youngest trees. No, winter juvenile tree dieback, those sudden cold freezes in November, if your tree is not dormant, it can really affect the young, very healthy, and strongly growing trees. So this is a good argument for cutting off that irrigation early. Canopy management, when does it end? Thus far, what we know is it goes for the bearing life of the tree, which we have not hit yet in California. You prune as long as that tree is producing. When do you prune during the season? It's best to make your pruning after the trees have fully lost their leaves in December and January during the dormant season, primarily because you want to You want to do your pruning before that hormone auxin starts suppressing bud break of lateral vegetative buds in the shoot below the apical bud, especially if you want branching. Let's just explain what a hormone is. A hormone is a chemical produced in one place in the plant in response to a situation in the plant that has a target elsewhere in the plant. Hormones are control chemicals. Basically, the function of auxins is to obtain food and our nutrients for the target. Auxin is the one that's in those apical vegetative buds. Auxins are produced in the stems, the buds, and the root tips. Their function is to maintain apical dominance. They enforce the dormancy of the lateral subterminal vegetative buds. Removing the apical bud stops auxin distribution that inhibits lateral vegetative bud break. If you wait too late to prune your trees and the auxins start distributing down that branch, the lateral vegetative buds that you hope break will not break. They will produce something more like this, where you see bare wood down lower on the shoot. If the apical bud breaks dormancy, it will suppress vegetative bud break if you do it too late. Okay, so now we're going to move into canopy management and how. You can do hand pruning and you can do mechanical plus hand pruning. And I'm going to make this point over and over again. Basically, there is no mechanical pruning without some hand pruning. Okay, hand pruning is what you use. You're going to need a saw, you're going to need a pair of loppers, and you're going to need a pole pruner. Mechanical pruning, there are multiple machines out there. This is one that's used for hedging. Okay. Okay. I'm going to go through the advantages and disadvantages. Okay. Hand pruning, it's precise. If it's done correctly, it's horticulturally correct and precise. The disadvantages, it's expensive, it's time consuming, it is difficult to teach. Mechanical pruning, the advantages, it's less expensive. We've demonstrated that it can decrease alternate bearing. You could, of course, do that also with hand pruning, just be a lot more cuts. Its big disadvantage is it's indiscriminate. There is no differentiation between the kinds of cuts a mechanical pruning makes. Now, we'll just talk a little bit about the function and how for canopy management. The function is to expose leaves to light. Our objective is harvestable yield, a harvestable tree, healthy tree, and yield. And right now, I'm going to get two assumptions out of the way. Yes, a bigger tree produces higher yield. Higher yield doesn't necessarily mean you get it into the harvest bin. And I will never argue with the fact that hand pruning correctly done is better horticulturally. Okay. But in the end, your decisions should be based on sustainability of yield, health of your orchard, and economics. How many dollars you take away per square foot of orchard floor in net return. Okay. If you're going to do canopy management, there's some things you need to know. You need to know how to tell the difference between a fruiting bud and a vegetative bud. You have to know the bearing habit of a pistachio. The bearing habit is that it produces on 1-year-old wood and it's very apically dominant. Vegetative growth is from the apical vegetative bud unless it is forced by pruning. You have to know what tools you have in your arsenal for hand pruning. You have heading and thinning cuts. And most importantly, you have to be able to recognize the tree shape that you want. So first, let's talk about the fruiting bud and the vegetative bud. I've put a real big close-up here to show you what a fruiting bud and a vegetative bud look like. The fruiting bud is bigger. I took the leaf axils off. I took the leaves and their bracts off so you can see them better. But the fruiting bud is big and fat. It stands up. The vegetative bud is tiny, it's more triangular, it hangs closer to the branch, and they often appear on different qualities of wood, especially on the same branch, because this wood is more mature, has more starch storage than this newer, younger wood. Okay? You have to be able to recognize the bud transition on a branch. If you go over here by the 4 inches or by the penny, you can see this growth starting to slow down, and these are vegetative buds versus by the quarters, you see fat fruiting buds. If you prune below the penny here, basically you're going to stop the growth on that shoot, and that shoot will die out after fruiting. Okay. You have to understand the bearing habit. We went through this already, but basically your fruit is back here, your vegetative bud is out here, and by the end of the year, after that crop is harvested, because of alternate bearing, this is what it looks like. I removed the bracts so you could see that the fruiting buds, for the next year's crop have abscised due to alternate bearing, but you still have vegetative buds out here that a cut up here or up here would spur branching if you want it that far out in the canopy. You have to understand the bearing habit, that it's very apically dominant, looks like this in the spring. By fall, looks like this, and that following winter, you're going to have to deal with those long shoots because you don't want them to extend another 3 feet. Otherwise, you're going to have a tree that looks like this. Okay. Another, the response, as we, just said my internet connection is unstable, which is odd because I'm in my office on the hardwired one. Okay. You have to know the response of the cut. If you go above something like this, where the buds are starting to be close together, a bud whorl, and you make a cut right there, you're going to get this kind of response, which is basically a bunch of small, shorter shoots coming out, some producing fruit buds. Now, this is not entirely bad. Perhaps you want to contain your canopy. You don't want it to get so large. So you can make a deliberate cut like that. It can be actually very productive looking at a branch like this, where a cut was made there, and there's still fruiting nodes, and the canopy is more compact. It's just that basically you have to recognize why you're making the cut. Let's talk about our types of pruning cuts that we have available to us. We have heading cuts, where the shoot is cut in half, the basal portion with less buds remains. It means you remove stored carbohydrates from the tree and you force the growth into the subtending and proximal shoot growth. You forced shoot growth below and next to that cut. Thinning cuts, the entire shoot is cut off at the base. You get less of a response, but it thins the canopy, gets more light penetration in, and it enhances the subtending shoot growth if it's made near other shoots. If this is a kind of cut that forces the canopy up. Okay, so here's a heading cut. Basically what it does is it destroys the apical dominance of this bud. Just a cut right in half like that. Encourages shoot growth, but it does alter the carbohydrate to bud ratio because you removed carbohydrates. In practice, this is what it might look like. There's a, I believe, 22-inch heading cut. Thinning cut, it removes the entire shoot. It doesn't alter the bud to carbohydrate ratio. You get less of a response. The tree canopy is thinned. More light is allowed to enter. And you get that kind of reaction. Here is an example of a thinning cut. Went back to the point of insertion and cut off the entire branch versus a heading cut. Okay? You have to recognize the tree shape that you want. As I said, you're going to keep seeing this over and over. A nice open trunk for mechanical harvesting, scaffolds going up, the scaffolds within the tree occupying their own space over the season. It's going to grow like this. And you're going to Going to grow like this, and you're going to have to deal with those long whips the next pruning season. So our desired canopy structure is compact and upright, accessible trunk, upright, short, stiff scaffolds, and the canopy thinned to decrease the damping that would occur with a thick canopy in mechanical harvesting. Now I'm going to go through the steps of hand pruning for canopy management. For the 4 steps, if you mechanically prune, basically you will be doing at least combining your mechanical pruning with step 1 here, possibly step 2, and definitely step 3, but not step 4. So steps 1, 2, and 3 may also be incorporated into mechanical pruning after the pruning, but they will not be as much in volume, but you will not be doing the 4th, tipping the whips. So you got 4 steps here. The first step is the step you can probably assign to your least skilled pruners. This is removing the low, flat, overlapping broken branches that won't shake or have been broken by the harvester. This is generally a thinning cut. It's done with your loppers or your saw. I'm going to make an argument for doing it with your loppers when it's less than 2.5 centimeters in diameter. The second is the outside thinning cuts. These are to push the canopy up, catch those branches that are at less than a 45-degree angle, are going to produce shoots that hit an inflection point and start hanging down when they start to get filled, when they start to bear crop. This can be done with loppers and pole pruners. 3, there's, as Bob Beatty always colorfully describes, and we will use his slides, inside, excuse me, this should be thinning right here. I apologize, it's a mistake on here. Well, inside heading and thinning cuts for a snake. You can use a loppers or a saw for these. And 4th, tipping the whips. This is where you use the pole pruner. You tip the top canopy. So we'll go through these one by one. Here's your pruning tools. Your first step, low, flat, overlapping broken branches. They either won't shake well or it's something broken by the harvester. This is a thinning cut. It's usually done with loppers and a saw. So basically here we have this low, flat branch here that has hit an inflection point here. And when it starts to have crop, it's going to hang down. This is a branch that I would advocate go back with loppers and remove. Here's another one that's starting to produce low, flat branches. This one would probably take a saw cut. Let's talk about how to do. First, I want to show you also, if you start to see these things in trees, probably broken by heavy crop and a harvester, this is when you really have to start to do this kind of cut. It should have been done earlier. So how do you prune these branches off? First of all, you don't cut the branches flush with the trunk. You preserve what we call the collar. It's that ridge in the bark around the base of the branch. The collar contains cells which make wound wood, which grows over a pruning cut. The branch collar also makes compounds to defend the tree against decay, so you don't paint or tar these wounds, these cuts. Here's how you do a cut like that. It's a 3-cut system. And like I said, this is for branches over 2.5 centimeters. I advocate getting out there with a lopper before it reaches this stage. But you do this cut to prevent bark tearing or damage to the remaining branches. Your first cut is right up here on the lower side, 1 or 2 inches from the branch union. Your second cut is a few centimeters forward on the upper side, and that removes the branch. The reason you do it this way is so you don't tear the bark lower on the trunk. Then you come in with your saw and you basically smooth off that final cut just above the branch collar so that it heals over like this. Actually, in this cut, I probably would have gone a little more flush, but this is what a nicely healed over saw cut looks like. Now I'm going to talk just a little bit about this kind of low flat branch removal on these more vigorous rootstocks. So these trees were about, if I think these trees are about 8 years old. It had a low flat branch coming out, but it started to tend up, and the grower made this cut right here, reasoning with this bud, he was going to get some good growth and some crop out here. And on some of these vigorous rootstocks in younger trees, this produced, I measured it, it was almost 4 feet of growth. And this cut, both of these would extend into the harvester and basically not be harvestable for yield. So what I'm going to advocate for is when you start to have these branches that are already starting to look flat and reach an inflection point where they drop, it's better to get them with a lopper cut than have to go through a saw cut later with things that are only going to get in the way of the harvester. Right now, I'd like to show you something that I was shown in the field 2 weeks ago. This is a Golden Hills on Pioneer Gold 1 seedling tree, both a very vigorous combination. It appears that this scion is beginning to develop the kind of bark inclusion that with heavy crop on lower hanging branches could result in harvester damage because of the stress of the crop on the tree when it's harvested, or even just breaking branches later. The solution that some of these growers are taking are braces driven through the tree, anchored by washers in both directions below the scaffold branching. Previously in California, I've seen these kinds of things, this kind of bolting and bracing done more up across the branch crotch, but they found it more effective to drive these bolts in 2 directions below the scaffold branch. They found that it deters, or they're hoping that it deters the breakage of branches in harvest. And they are trying to train the pruners to look for when problems develop below it, as they call it, a smile. Okay. Now we're going to talk about, go back. Now we're going to talk about 2, the second step, outside thinning cuts, where you want to, stop. Okay, outside thinning cuts, I better move. You want to push the canopy up. You want to get those branches at less than a 45-degree angle so that they don't start to have an inflection and drop the crop down. This is done with loppers and pole pruners. Here's our example tree. This is where one of those cuts was done to force this growth up. This was where another one could be done or was done to force growth up. And here, over here, to force growth up. And over here, basically, it's about time to make another cut, maybe further back in to force growth up. The purpose of this kind of cut is to keep the canopy, the whole canopy, within its allotted space and to force growth up and toward the tree to eliminate the kind of hanging branch with crop that won't harvest. Okay, then I'm going to show you a series of pictures developed by Bob Beatty. The next step is inside heading cuts. These can be done with loppers or a saw, less frequently with a pole pruner. And basically what you're looking for is what Bob Beatty calls the snake. A branch that goes up through the tree, doesn't have much branching on it, goes up to the top, has some branching, and decreases sunlight. He advocates removing these, as we demonstrated, with a saw and introducing more light into the canopy. Okay. Step 4, tip the whips. This is the step that is not done if you're combining with mechanical pruning. It's done with pole pruners. It's removing that growth at the top of the tree that grew all summer on the more vigorous rootstocks. When you go out to see it in the dormant season, this is what it looks like from the ground. If you're lucky enough to have a platform and be able to reach over, you can start to recognize the whorls that you want to prune below. Or perhaps you basically want to go down into this wood with more carbohydrate storage. But the point is, because you're doing this, you basically want to prune above a vegetative bud or a series of vegetative buds to induce some branching. It can result in things like this. If you make a cut like this, it can push latent buds out below and produce some branching like that, even though the branch that you tipped will die. I'm sorry about this mouse, okay? Again, what we're looking for is a nice accessible trunk, upright canopy with upright canopy with the scaffold staying in their area of the canopy. Okay, now we're going to talk about mechanical pruning. Mechanical pruning is, as we said, indiscriminate, cannot be done without hand cuts also. Basically, what has been developed over the years, we have not actually done research on this, so it's more gathering from people who do it. Topping is used to control height. Basically, try to keep that tree below 15 feet, and the topping can be done annually. Otherwise, on these more vigorous rootstocks, you're going to get those long whips. Hedging, what has come to be the pattern is hedging every other year, every other row. One, the hedger can move faster by not having to make tight turns. And two, you're only cutting about a third of the tree surface. So every other row middle, every other year. If you have a situation where you really want to contain the canopy, you can cross hedge across the berms. One thing that is key, if you're going to do topping and hedging, you want to have good orchard floor maintenance. Something like this, oh darn it. Something like this or this, hitting a swale or a hump will cause those blades to move a great deal, and you're either going to get a tree that gets missed or a tree that gets really pruned. Okay, this is what last week.
Louise, you're out of time.
Okay, well, basically, this is what a mechanically pruned tree looks like. Notice that nice dappled orchard floor. Here are your costs, $300 to $500 per acre for hand. Mechanical, you're looking at about half that to a third of that. Just remember, there is no mechanical harvesting without tree training and pruning, and we've gone through all these steps. And here's a series of links. The first is your production manual. Go read chapter 12. The other 4 are videos where you can watch Bob Beatty and Chris Wiley prune those 4 steps I told you about. Thank you very much. I'm sorry I ran over.
No worries. So we have a 15-minute break. And so I guess if Louise, you don't mind, you could answer some questions, or you could just type them into the question and answer box. So what would you like to do?
I'm happy to stay and answer questions.
Okay. So first question, I'll go through. Okay, so was wondering why hedging is encouraged when all along we are told to make our pruning cuts to have fruit buds set in particular places and such. Hedging and topping can't dictate where the fruit buds are and make appropriately located cuts.
Okay, so basically, that's a very good question, because it's at the heart of mechanical hedging and topping versus hand pruning. And the answer is that basically, economically, it has been demonstrated with the lower cost. Basically, it doesn't harm the tree in terms of sustainability, and it's cheaper and logistically easier. So it's basically a financial and management decision. As I said earlier in the talk, I will never argue that hand pruning is not horticulturally correct, but you base your decisions on your net returns and the sustainability of your orchard. And mechanical pruning has not been demonstrated to harm the tree. It can maintain the canopy volume and shape you want, but it cannot be done without some hand pruning cuts, primarily those low branches, those snakes in the canopy, and fewer, but still some cuts to force the growth up and in.
Okay, so the next question is pretty closely related, but it's when to hand prune versus mechanical prune.
Basically, the dormancy of the tree doesn't change. So if you mean when within the season to hand prune versus mechanically prune, you would still do it in December and January. Try to do it well into the dormant season, but before you're flirting with dormancy breaking early. In terms of tree life, the transition is made generally in the 6th to 8th year after the tree has started to have its first crop and crop starts slowing down the tree growth.
Can you share the formula for the alternate bearing index? And I guess I'll say last time I looked, it requires summation symbols that you can't put into the chat, I think.
I'll be happy to share it, but basically I'll tell you what it is. You basically take the first year's yield and subtract the second year's yield and divide that by the sum of the two for every successive year set. I can put that into the PowerPoint because I have to correct 1 or 2 errors in the PowerPoint. So I can put that in the PowerPoint and have it sent to you. Also that paper that I referenced by Ferguson, Beatty, and Moranto from 1995 has the formula in it. But it's basically the difference between 2 successive years divided by the sum of 2 successive years, that total sum for the number of years you did the experiment divided by the number of years you did the experiment.
The next question you did kind of answer in the talk, but they're asking whether there's a difference between pruning in on or off years for the platinum rootstock.
Based on Bob's data that I showed you, the pruning versus the on or the off year does not affect alternate bearing on the platinum rootstock. And I would like to say that, and realizing that the data that was generated was on a run of seedling rootstocks. Each platinum rootstock, meaning the cloned ones, you may get a more uniform response, and it might not be quite what I got because we were using a seedling population. Bob was using a seedling population.
Okay, next question is, do you recommend to prune every year or every other year? Which I think you answered as well in the talk.
Mechanical pruning?
It doesn't specify.
Yes, I recommend pruning every year. Situations can get out of hand very quickly. You saw those whips. They were already 3 feet above the tree. By the end of the season, on some of these vigorous rootstocks, the next year they'll be 6 feet and they'll be hanging over.
Okay, so the next question, do you recommend to cut off water, or when do you recommend to cut off water on developing pistachios?
Based on some of the things that we have seen in the past 2 or 3 years, I would say before August 15th. It's been very impressive to see young trees, especially those in that 4 to 6 year age, to see the scions completely dead from a sudden November freeze, especially when they might be in saline ground and the water content is higher than you would expect with a normal irrigation schedule.
Yeah, I guess I don't know what it's like up there, but we've had a pretty cold night last night, and we're gonna have another cold one tomorrow. So yeah, we'll be seeing some of that next year. When is it considered to be too late to prune?
I would not like to see you prune, especially with the Golden Hills, past the end of January.
Okay. Do you have any thoughts on chemical defoliation and storing carbohydrates going into the winter?
Well, I'll go see Dr. Mashi Zuwanicki's Carbohydrate Observatory, but basically with younger trees in the nursery, we We advocated, and younger trees in the orchard, we advocated defoliation during the training period with zinc sulfate to make sure the tree goes dormant and is not as susceptible to cold. But the data that's being developed now with Dr. Zwernicki is the longer we can keep those leaves on, the more carbohydrates we store. We have to balance that with our propensity for earlier sudden freezes. So at this point, I don't have any good data-based information about defoliating a mature tree early chemically.
Okay, so with Golden Hills naturally growing upright, do you recommend maintaining the canopy in a different way to promote lateral growth to increase the fruiting potential?
That's a very good and logical suggestion, which suggests what you maybe want to do with Golden Hills. But I'm going to defer to the expert, Craig Carlson, but it would seem to me what you would want to do is some more of those outside canopy thinning cuts to produce outside thinning or heading cuts that would produce some branching. So it is more upright, so we want to spur it to branch, but keep it going upright. Unfortunately, we don't have any good trials on this, but I believe Julia Marino and the farm advisors down in the San Joaquin are going to be putting in a trial to examine this fall. So the real answer is Craig has the best experience, but we don't have any real trials on it yet. And if Craig's out there, he can correct me.
Okay, so next question. Can high levels of nitrogen fertilizer applications increase excess vegetative growth and have a negative impact on nut production and yield numbers?
Well, based on all horticultural knowledge about excess nitrogen, yes, it can, except Patrick H. Brown has also demonstrated that pistachios are not luxury consumers. They pretty much take up what they need, though during the season. But having said that, I have seen high leaf levels, and almost with any plant, if you give it a lot of nitrogen, a lot of water, just like giving a teenager too much money, they won't work.
Okay, it's another question on the alternate bearing index. Can you explain it really quickly?
Sure. Basically, the alternate bearing index is a numberless unit on a scale of 0 to 1. If you have 0 alternate bearing, you have the same crop each year. If you have total alternate bearing, you have no crop one year and a lot and excessive crop next year. I've seen orchards in California go from 60 pounds per acre to 6,000 pounds per acre with alternate bearing. And I would like to explain with that one experiment we did, that was more of a reconstructive experiment in the sense that the trees were alternate bearing very severely when we did that treatment. Now, what I'm noticing is people are starting the topping, which is the step that decreases alternate bearing most. They're starting it earlier in the tree life, perhaps 6 to 8 years, when it looks like it would be almost too many hand pruning cuts. And in fact, one of the consultants out in the industry told me, we charge more for hand pruning 6 to 8 year old trees because of those tipping cuts, which if you have a good topper, it doesn't bend those whippy branches over and skin them, is going to be equally effective, except for the fact that it's indiscriminate. So I'm an advocate of starting the topping and pruning earlier and decreasing the alternate bearing. But then as Bob Beatty's data showed, as long as you do the pruning, you can do it before the on or the off year.
So next question, is there any cheaper way to control suckers other than manually on a 5th-year-old tree?
Oh, thank you. Because I forgot to put suckers into the talk. Thank you for that question. Basically, get rid of suckers as soon as you see them. Unfortunately, like olives, we don't have anything registered to stop them. So basically, suckers are a lopper cut. Thank you for that question. I forgot to put it into the presentation.
Okay. So I'm skipping some questions here because a lot of them were addressed in the talk or other questions. But if you have a fully mature tree that is completely haphazardly growing, it looks like a massive bush, what would be your approach to pruning it back to a more appropriate shape?
I would basically go in, decide the volume of tree I want, top and hedge it. Then I would go in with those low lopper cuts to get rid of the flat stuff, and then go inside the canopy to try and get the scaffolds that are shading the interior of the canopy. So I bring in the big steel to get it down to the size I want, and then I would use the low cuts to get it going up, and then I'd go inside the tree and thin it out to get light in there. And then I'd be prepared to not have much yield that year, and maybe to do some heavy pruning the next year, because you're going to get a strong vegetative response.
Okay. Well, we don't really have any time for other questions. So if you wouldn't mind sticking around, Louise, and answering some of the other questions in the chat, and we can move on to our next talk.
Sure. So I'll go into the Q&A and answer the questions.
Yeah, you can do that way.
Okay, great. Thank you, everybody. And I will send a PowerPoint with those few little things corrected that I noticed.
Okay, so our next talk is by Houston Wilson, who is the entomology specialist for UC Riverside, based at the Kearney Ag Center in Parlier, California. And he's going to be going over navel orangeworm biology and management. So I will set a timer, Houston, and I'll just butt in when you run out of time.
Okay. Okay, let me get my screen share here. Can everybody see this? Looks good.
Yes, looks great.
Okay, cool. Thanks. Yeah, thanks for the introduction, Phoebe. Always a pleasure to talk at the Pistachio short course. So I'm an assistant cooperative extension specialist with the Department of Entomology at UC Riverside, but my lab is based at the Kearney Ag Research and Extension Center in Parlier. So today, going to be talking about navel orangeworm biology and management in pistachios in particular. So just an outline for what we're going to cover today. Going to look at the origins and distribution of navel orangeworm in California, go over some of the basic biological parameters, basically how does this insect operate in orchards, and then of course spend a fair amount of time on management, which includes a kind of whole suite of practices, cultural, biological, chemical, etc. Also want to point out here at the beginning, and I'll reiterate this at the end, this is a kind of round the world tour of navel orangeworm in 60 minutes. But want to reinforce everything I say with the other resources that you have available to you. Of course, that starts with your local farm advisor or IPM advisor. You've got the website there to look up who your person or people are in your county or region. Of course, the UC statewide IPM program website is a fantastic resource for not just navel orangeworm, but all pests and diseases of pistachio, along with many other crops in the state. And then, of course, the relatively recent new pistachio production manual. So you've got the publication number there and a website link to look that up. So these are kind of all things that you should have in your back pocket to help you get your management of navel orangeworm down. And these folks can provide a lot of more specific detail at the ground level. So, okay, origins, arrival, and current pest status of navel orangeworm. So this is a lepidopteran pest. It's in the family Pyralidae. It was initially, the reports of it are from kind of neotropical, subtropical regions throughout Central and South America, Mexico, and the Caribbean, stuff going back to the 1800s. The name navel orangeworm is somewhat misleading to many newcomers into tree nuts, given that it's primarily a pest of tree nuts and not citrus. This stems from the fact that it was first reported in the US attacking split citrus in Arizona. So there's these early reports from the 1900s. Just got some screenshots here of some of those things. The new orange worm. So the association with navel orange worm is what initially led to it getting this name. That instigated quarantine efforts to keep it out of California back in the 1920s. We had and continue to have a thriving citrus industry here. Those failed, and in the 1940s, we had our first reports of navel orangeworm in California, not only on citrus, but also walnuts and almonds. Of course, there were no reports from pistachios because we didn't have them in the state until the 1970s. And shortly or soon after the development of pistachio orchards in California, we had reports of navel orangeworm on pistachio as well. So the original name stuck, but it is considered the dominant pest of almonds and pistachios, as well as walnuts. And those tree nuts are much, much better host for it than something like citrus. We'll talk a little bit more later about some of the specifics about crop vulnerability, but something like citrus is really kind of impenetrable to navel orangeworm because of that thick hole. It can't really get through that unless they're already split. So that's kind of the timeline for its arrival into California, and it quickly spread throughout walnuts and almonds and all the other tree nuts. Current pest status. So we have an extremely low tolerance for navel orangeworm damage in all tree nuts, typically around less than 2%. I know many growers looking for less than 1% infestation. And this is driven primarily by two main factors. One, it's a high value crop, of course. You have navel orangeworm infesting nuts, that's lowering your crop yield and quality. It's a very straightforward thing. That infestation also leads to increased processing time and cost. It's more effort to get those infested nuts out of your loads. So you'll make your processor much happier to have lower crop infest. And then higher infestation, it's always a struggle to get all of the nuts out of the orchard. And one of the biggest drivers of navel orangeworm populations is the overwintering population in remnant mummy nuts left behind in the orchard. So if you have a lot of infest, a lot of your mummies are likely going to be infested, and that's going to set you up for a larger base population in the year to come. The other main factor is the relationship between navel orangeworm and aflatoxin. So navel orangeworm are able to introduce Aspergillus flavus. This is a fungus that can lead to does lead to the production of aflatoxins. These are known human carcinogens. They're heavily regulated both domestically as well as in key foreign export markets. We know that the adults move this fungus around, and then the feeding from the navel orangeworm larva actually creates opportunities for that fungus to grow in the nuts. So you have infestation that's affecting your crop quality. That's also potentially introducing aflatoxin into your loads, which can present a significant problem. So we know this thing's a pest. It's been here since the 1940s. So the biology, behavior, and ecology of navel orangeworm. So it's a Lepidoptera, that's moths and butterflies. All of these go through a metamorphosis. So you have the four life stages here: egg, out of the egg comes a larva, larva feeds and passes through multiple larval stages, and then eventually pupates. And then out of that pupa emerges a big, healthy navel orangeworm adult. So the navel orangeworm adults, they deposit eggs directly onto the nut. So this is some imagery showing you kind of a series of different scales here. Here's a navel orangeworm on a pistachio that's split. We zoom in, you can see the little navel orangeworm egg there. We zoom in, and that's what the egg looks like under magnification. So the egg is going to hatch. You have a larva come out. Those are going to feed on the nut meat, the kernel of the pistachio, and then spend their entire life inside of that nut, feeding on the kernel. And then they eventually pupate and become an adult, as I mentioned. As they feed, they, of course, produce a lot of frass. That's basically their excrement, which you can see here. This is a picture from almonds, of course. And they also create this webbing, kind of like, almost looks like spider webs, kind of a thicker, silky type of webbing in there. So this frass with the webbing is a really telltale sign of navel orange worm. In pistachio, you're not really going to run into other worms in your nuts. So more often than not, if you find a worm in there, it's going to be navel orange worm. The larvae, you can distinguish them. They have this crescent-shaped mark on the second segment behind their head. The mark is on both sides. This is just showing the left side of a larva. So that's one distinct feature. The color of the larva can vary depending on their food source. They can be cream colored, they can be kind of pinkish, kind of reddish, like you're seeing here. But again, the frass, the webbing, that's really your telltale sign, along with the fact that you just don't have a lot of other worms attacking pistachio. The adult, you will see these on traps. We'll talk about that in a minute. The family Pyralidae that it's a part of, they have this, they're known as snout moths. So they have this little pronounced kind of snout looking thing. Obviously a little bit more difficult to see on when it's crushed on a sticky liner versus this really nice photograph from the USDA, but you can see it. Okay, so pheromones play a really important role in the life cycle of navel orange worm. So this moth is active at night. It's nocturnal. The adults will emerge from their pupae at dusk. So once it passes through those larval developmental stages, pupates, and then metamorphoses into an adult. A virgin, an unmated adult will emerge from that pupa at dusk. And then they go about finding the males and females, finding one another to mate, typically on that first night out in the orchard. And then having mated will then go on the following night to begin, the females at least, to begin depositing eggs. The way males and females find one another is through the use of pheromones. So the female navel orange worm will emit a pheromone that the males are able to identify and follow the plume of pheromone up to her. So this photo I have here, this is a female that we actually covered in this fluorescent dust, so it was a little bit easier to photograph her at night. But you can see she's got her abdomen up like this, and this pheromone gland is kind of sticking out of there even. And so you'll see females, if you spend a lot of time like I do in orchards at night looking at navel orange worm, around 2 a.m., 3 a.m., you'll start to see females calling, and they're putting up their abdomen like that. You obviously can't see the pheromone, but that's what they're doing. And so you have this plume of pheromone emitting out, and kind of like a breadcrumb trail or something, the moths will follow, they'll detect that plume and then follow it upstream until they find the female. This happens in the middle of the night. Typically males will be able to locate females in the very last few hours of the night, and they then kind of go through a little song and dance to eventually start mating. And this is a photo here of a male and female, what we call in copula. So they're kind of joined together. They spend about 2 hours like that while the male passes his genetic material over to the female. So they'll mate kind of through sunrise and then kind of rest for the rest of the day. And then the female goes out, like I said, that following night to go about depositing eggs on nuts. Their broader life cycle over the course of the season, they overwinter as larvae or pupae in remnant mummy nuts. The adults emerge in the spring from those nuts. They're able to complete in California 3 to 4 generations per year, depending on weather and host quality. I'll get a little bit more into that in a minute. The population, the population of navel orange worm develops more rapidly as the season progresses. So you have these 3 or 4 generations per year, but they start to become larger and develop more rapidly as we get closer and closer to harvest. That's due to a convergence of multiple factors. You of course have warmer weather. The temperatures drive the development of these insects. They also develop more rapidly when they're able to feed on new crop versus mummy nut. So a new crop nut is essentially healthier, has more nutrition for the larva, so they're able to develop more rapidly and have higher probably survivability on those new crop nuts versus mummy nuts. And then of course increased host availability that happens with whole split or whole slip in pistachio. So you got to imagine there's so much of their ability to attack all tree nuts, but pistachios in particular, is moderated by the integrity of the hole. If they can't get through that hole on their own, they're similar to what I was saying about their ability to access navel oranges. They can't bore through an intact hole. Their mouth parts aren't well developed enough to do that. So their ability to access the nut and cause crop damage is mediated by this hole breaking down and shell split and basically having access to the nut itself. So this is a figure from UCIPM showing the different life stages and the approximate timing of these navel orangeworm flights. So here's your overwintering larvae, which then generates your first flight in late March, April, May. They then oviposit onto mummy nuts that begets more larvae. Here's your second flight, and you can see the process going on and on here over the course of the season. This third versus fourth flight, depending on the region and the temperatures and how quickly the population has developed, some fraction of these larvae that come out of this third generation may actually just be the larvae that go into the winter period, versus some that are able to develop rapidly enough into a fourth generation. And then that fourth flight, that's generating the larvae that also overwinter. So, they hit a certain photo period and changes in nighttime temperatures. They kind of trigger they're moving into this overwintering mode or not. This is the same figure, of course, just overlaid with some additional information. So what I've put here is the primary host that they're making use of. So this being the mummy nuts that they overwinter on, but then that first flight in the spring in April or May, there's still not new crop nuts available for them to make use of. And so they not only overwinter in these mummy nuts, but then they actually use them as a reproductive substrate for that first generation of moths. So when we get into management, I'll just be hammering the importance of crop sanitation, but this is kind of your first taste of that. These mummies are not only provide an ability for navel orangeworm to make it into the next season, but they actually help them grow their population with that first generation. By the time the second flight is happening in July or August, there's new crop nuts available for them in almonds. You have whole split and almond happening in early July. So those nuts are available. So that second flight, they're going to be ovipositing onto those. If you do have early splits in your pistachio, those are also now vulnerable to navel orangeworm. And you can, we'll talk about this some more later, but that also provides them, the ability to get a foothold in your orchard and get some healthier food and develop a larger population. So their primary host in this period now being new crop nuts, whether it's almond or early split pistachio. But then I put mummy nuts here in kind of small font because they still are able to make use of some mummy nuts. And we see some infestation on mummies. Some earlier studies were showing this, throughout the year. Of course, they much rather would go on the new crop nuts, but mummy nuts are a problem still throughout the rest of the season. So again, all the more impetus to get them out of the orchard and get them destroyed. This third flight, this is the most critical one for infestation in pistachios. This is happening in early August. You're getting whole slip much more frequently in pistachios around this time of year. So now your pistachios are basically fully becoming vulnerable. This is critical for the timing of insecticide controls. Again, we'll talk about that more later. But again, here using new crop nuts, of course, and then some mummy nuts. And then here, this fourth flight in kind of more southern parts of the Central Valley where it's warmer, you're also getting them, of course, on these new crop nuts, which, at this point in the year, these are going to now become your mummies, right? So any of the new crop that isn't effectively removed from the orchard is now potentially an overwintering host site for navel orangeworm. So, showing their population size kind of exponentially growing here over the course of time, increasing temperatures, increasing host quality, increasing host availability, all of those contributing to the growth of a population and that faster and larger population growth. So what I'm showing here is the number of males trapped per week in pheromone traps in one of our orchards where we frequently work with navel orangeworm. And I think this is just a given year, but it captures what these population trends look like, right? So here is your first flight. That's kind of that little bump of everybody who was able to successfully overwinter. Those guys are reproducing on mummy nuts, which are not the best host out there, but it's kind of all they've got, but they're able to make it through. And so you get this second flight, slightly higher than the first one, but still fairly muted. But then it's this second flight that's getting on to almonds, and it's getting on to early split pistachios if those are there. And look what happens. Flight, huge, exponentially greater than the first and second. And then at this point in the year, you've now got those pistachios are becoming vulnerable. They're able to reproduce on those. And here's the fourth flight, a little less distinguishable from the third, because at this point in the year, you're starting to get such high populations. You're getting some asynchrony in their life stages. And so the third and fourth flight can kind of merge into one another. So it's just this time of year, starting in August, when the populations are just enormous, and you've got your crop susceptibility at its maximum. So it's really the most critical time for control, as well as to make sure that you're getting your nuts out of the orchard as early as logistically possible. And again, we'll get more into the timely harvest issue here in a minute. So integrated pest management of navel orangeworm, we've got, like I said, a suite of practices, all of which are very important. And I'll immediately highlight that the key to success here is using multiple points of attack. I really can't emphasize that enough. There's not one single thing that's going to single-handedly keep your crop from being infested at a rate higher than what you're aiming for. So the key tools here: sanitation, destroying your mummy nuts; biological control, natural enemies that predate and or parasitize navel orangeworm; mating disruption, that is a way to reduce the mating and reproduction of moths; monitoring, not so much a control strategy, is part of doing your control more effectively. So a combination of egg traps, flight traps, using that information to set a biofix and estimate degree days or calculate degree days to estimate phenology. Again, I'll get into all this here in a minute in more detail. That really helps you with monitoring just the relative population you have from year to year, but then also really helping you to dial in your spray timing in order to maximize impacts. And then early and timely harvest, as I mentioned, largely a logistical exercise. We can't quite make the crop grow and mature any faster necessarily, but having your equipment and machinery in place to get the crop out of the field as relatively quickly as possible. So going into detail now on each one of these. Crop sanitation, we'll start off with that. So as I mentioned, navel orangeworm overwinter is larvae and remnant mummy nuts, and these are larvae that then become the base population for the coming year. And those mummies, as I mentioned before, are also reproductive substrate for moths in the spring. So it's kind of a double whammy to have these things out in your orchard. And this is just photographs showing mummy pistachios in a pistachio orchard. So how to do sanitation. One of the first steps is simply harvesting in a timely manner. So like I said earlier, making sure that those nuts that are out in your orchard, that then inevitably you're not going to get everything out of there. So by getting harvest taken care of in a timely manner, you're minimizing the exposure of the nuts to navel orangeworm. You're reducing the infestation rate of those mummies subsequently. But then really the direct part of crop sanitation. So following harvest, you want to get all of the mummies onto the orchard floor. And you can do that by reshaking trees or by hand pulling trees to remove mummies from the canopy, from the tree crotches, from everywhere up in the tree. Get them down on the ground. A mummy on the ground has a much harder time, or a navel orangeworm in a mummy on the ground. It's known that there's higher mortality of navel orangeworm in those mummies, but then also, of course, getting them on the ground is a key step in sweeping them together, aggregating to them together, and destroying them. So you get them out of the tree, you blow them off the berms or sweep them off the berms to aggregate them in the row middles. and then you can mow or disc the mummies to destroy them. Now, we know that this is more difficult in pistachios because they're a smaller nut, as versus trying to do a similar procedure in almonds or even walnuts, where you have a much larger thing to be able to pick up and destroy with a mower or by disking under. But this is the basic process, is getting them out of the canopy, sweeping them together in the row middles, and then use a mower or disker to destroy the mummy nuts. This is data from Ingle and Barnes back in 1983, publication they put out. This is from almonds, but also data that David Haviland put into a slide form here, a figure, that really captures this relationship between the abundance of mummies in the orchard and the percentage of navel orangeworm infestation of almonds at harvest. So you can imagine it's a similar relationship likely in pistachios. And so the more mummies that you have per tree out there, the higher your infestation is. I mean, it's basically a linear relationship. So the fewer mummies you have in your orchard, the lower crop damage you will have, because it cuts down their overwintering population. It removes reproductive substrate for them in the spring and summer. So you want to sanitize as soon as possible after harvest, simply because it's unclear in a given year how the winter conditions are going to be in the orchard. That can be a major limiting factor if it's too wet to get equipment into the orchard. So you want to try to get on this as soon as possible. We know that weather conditions can lead to some mortality of overwintering navel orangeworm. So overwintering larvae does worse in a colder, wetter climate. And from some other work that we've done, we know that there's kind of this hierarchy of navel orangeworm mortality on mummy nuts. So a mummy in a tree canopy is kind of an ideal place for a navel orangeworm to overwinter. So we know that mummies on the ground fare worse than those in the tree canopy. There's more moisture, there's microbes, there's predators and things down there that can lead to the decomposition or some sort of other mortality effect on navel orangeworm. Mummies that are on the ground do worse if they're in ground covers, so versus on bare soil. So again, even more changes in moisture and microclimate that can affect mortality. And then moist bare soil leads to more mortality of mummies versus on dry bare soil. So, again, a mummy that's in the tree canopy, it's dry, it's off the ground, it's kind of protected. That's a really great place for a navel orangeworm to survive the winter, as versus a navel orangeworm in a mummy that's in a wet, cold ground cover down in the soil. All that said, I'm just trying to point out some of these mortality factors. I do not want y'all to leave it up to weather and microbes to take care of your overwintering navel orangeworm populations. You absolutely have to go into the orchard, aggregate the mummies, and destroy them. But just to highlight some of these other features that can affect their mortality. Okay, biological control. So early on, there were evaluations of the native predators and parasitoids that we have in the state, their ability to attack and reduce navel orangeworm populations. And this was in the 1950s and 60s. We have some native parasitoids, we have some native predators, but they really weren't that specialized on navel orangeworm. So there were two big foreign exploration efforts back in the 60s that culminated in the introduction of two different parasitoids. One is Goniosis legneri. This was a guy, Fred Legner, down at UC Riverside, went out to areas in Uruguay, Argentina, and Texas to locate this parasitoid and introduce it into into California. Goniosis, here you can see it in the image, they attack the larvae. So they lay their eggs, they parasitize the larvae externally. You'll see a larvae, if it's parasitized by Goniosis, with these eggs actually on the outside of it. The other one was Copidosoma plethorica. This was a parasitoid imported from Israel and Mexico separately by a researcher at UC Berkeley, another entomologist Leo Caltagirone. So you kind of have the Riverside parasitoid and the Berkeley parasitoid being introduced into California back in those days. This one attacks the eggs. It's an egg larval parasitoid. It has a really fascinating behavior. It's polyembryonic. So it'll parasitize an egg, and instead of just generating one single parasitoid, it'll actually generate like hundreds of parasitoids out of that. And it slowly kills the larva as it develops, and then pupates and kind of explodes out of the larva with hundreds of these other parasitoids. The problem with both of these is that they are not very effective at low navel orangeworm densities. And this work was taking place at a time when infestation levels, there was a little bit higher tolerance, and it was thought that these could potentially generate some control. But in the modern situation where we're trying to keep populations at a less than 2 or 1% infestation rate, it's just not enough host available for these parasitoids to build up an adequate population to much less to get us to the control levels that are necessary. So they are in the orchard, they're out here, but they're in very low populations, and it's really not a very reliable natural enemy system for biocontrol. Vertebrates, there are birds and mice that eat mummy nuts and or knock them out of the canopy to the ground. The impacts of that remain somewhat unclear. Again, nothing to rely upon. And then predators, you have lacewings, and then these small plant bugs in the genus Phytochorus. And I'll talk a little bit more about the latter here. So we have 2 species, Phytochorus relativus and Phytochorus californicus. These are small plant bugs. They attack navel orangeworm eggs. They attack some soft scales, and they also attack young pistachios. So it's sort of a complicated dilemma to basically make the determination, is it a good bug or a bad bug? There are some insects like this that both attack other insects and attack plants, and in some cases those plants, like here, are the plants we're trying to grow. So Phytochorus can be a benefit to navel orangeworm control. There's some earlier studies really highlighting that. But of course, as a grower, as a PCA, you've really got to weigh the trade-offs with the value of controlling all the other small and large plant bugs that are in your orchard with that contribution that Phytochorus makes to biological control. Monitoring is critical. So you can monitor all these bugs with sweep nets on the ground covers in the orchard, and also beat samples of the clusters in the canopy to see what you have out there. This is a good point to plug UCIPM. You can go to the website, you can look at, there's identification tools there to show you what these things look like and how to do some of that sampling. The issue we're dealing with now is that some of the newer pyrethroids appear to be much more detrimental to these Phytochorus predators. So those being the key products being used for plant bug control generally, we're seeing a lot higher mortality of the Phytochorus when we spray these for control of other bugs. So again, it's hard to say, again, you've got to look at, your other plant bugs you're dealing with, how high are those populations relative to the amount of control you might be getting from Phytochorus in a given orchard. Okay, mating disruption. So this is kind of a newer strategy. The basic idea here, we talked about how males find the females by following these pheromone plumes. What we've been able to do is characterize the chemical composition of those pheromones. This is work that took place back in the 1970s and 80s, and actually synthesize some of those key components and then spread them out through an orchard in a way that essentially makes it impossible or very, very difficult for male moths to find and follow that plume of pheromone. They can't, it's difficult for them to distinguish what is the real pheromone, or it just interferes with their ability to detect pheromone at all. So kind of a simplistic illustration here, but here's males following a plume of pheromone, and then here's all your synthetic pheromone kind of distracting them away from successfully doing that. So right now we have multiple commercial products available and multiple types of ways to put that synthetic pheromone out into the orchard. There's 4 companies marketing this stuff. It's all the same pheromone component. It's just, as I said, different systems to emit it. So One thing is the aerosol emitters. We sometimes call these puffers. It's a aerosol canister with the pheromone. There's polymeric emitters. It's kind of like a rubbery tag that's impregnated with the pheromone. So instead of a single puff, here, this thing is essentially constantly giving off the pheromone. And then most recently, these flowable formulations that are microencapsulated. So you spray them in the orchard, similar to any other liquid spray. So I put these into two categories. You have active versus passive emitters. The active emitters, the aerosol and the flowable. As I mentioned, the aerosol, it's a pressurized aerosol canister. You typically, depending on the system, put these out at 1 to 2 canisters per acre. And they're programmed to spray at some frequency over the course of the night. So remember, it's a nocturnal insect. They're doing this pheromone communication in the nighttime. And so you have, a little clock in here and it sprays the can at some frequency during that nighttime period. The microencapsulated flowable, like I said, it's a liquid that you apply like a pesticide. It's being marketed as having a 30-day activity period, which means you would want to apply it multiple times. Again, there's a lot of work to kind of suss out how to most effectively do this, and data is kind of still being generated on this. Passive emitters, the polymeric strips, like I said, a rubbery material impregnated with a pheromone. These need to be set out at something like 15 to 20 emitters per acre versus the canisters where it's 1 to 2 per acre. But they do passively emit pheromone all the time. So there's potential for more consistent coverage. Although, I think arguably the puffer system is, assuming you don't really need pheromone out there during the daytime because moths are they're not active and they're not looking for pheromone at that time. So just kind of characterizing the different systems here, basically. This is data that was shared with me from David Haviland. Many thanks to him for this and many other figures here throughout this talk. David did a great job of going out and actually comparing side by side all of these different mating disruption systems at the time that were available, 3 different aerosols and the polymeric emitter from these different companies. And essentially showing that all of them are very effective. This is crop damage relative to a control, and it effectively reduced it by 50%. So all of these products can be very, very effectively used to control navel orangeworm. Now, so it's really just a matter of picking kind of what system works best for you across the different companies that are offering these products. Some key considerations for mating disruption. Mated females can still migrate into your orchards. So even under mating disruption, you can have migrants coming into the orchard to attack the nuts. So mating disruption, we typically recommend that it's used in large contiguous areas. So that's square blocks greater than 40 acres, ideally greater than 100 acres. So it's hard to do this on small acreage unless you and many other small acreage people in kind of your area all band together and do an area-wide mating disruption program, which has been done in other crops and very effectively so. So you kind of operate as one big contiguous area together. Mating disruption will shut down your pheromone traps. We're going to talk about how these traps work in a minute. And that kind of leads you to fly blind a little bit with your monitoring. But there are more recently these phenylpropionate lures, PPO, that will remain attractive under a mating disruption situation. And egg traps also will remain attractive. So you do still have some trapping options available to you, but beware. I mean, it's good on one hand to see your pheromone trap shut down in the presence of mating disruption. You know that the product's working, but at the same time, you can't track flight. So there's that trade-off, but hopefully PPO does provide an option to still do that. The background navel orangeworm population is really important when you're thinking about using mating disruption. So we think mating disruption works best with lower populations versus larger populations. The basic argument being that with really high background populations, there's a higher probability that males and females will still find each other almost by happenstance, even in the presence of mating disruption. So when you're going into a situation to think about using mating disruption, there's some approaches that might merit more aggressive chemical controls to get that base population down, paired with, of course, very aggressive sanitation. And then once that has been achieved, implementing mating disruption thereafter. Okay, monitoring. I've been talking a lot about these flight traps and stuff. So some key points here: with a 2% damage threshold, economic thresholds for this pest don't really exist. And the monitoring is really to track insect phenology to determine your spray timing. And just like our management approaches with trapping and monitoring specifically, no singular method is perfect. And we highly recommend that you use multiple trap types. Populations of navel orangeworm can be very variable across 640 acres of pistachio. So more traps is going to be better than fewer traps. So overwintering larvae, this is one thing you can monitor. You can examine nuts around 20 trees in a block, count the total number of mummies, crack them out to inspect for navel orangeworm larvae. And this will provide you info on the relative abundance and infestation rate of the mummies in your orchard. Just effectively kind of a year-to-year thing to give you a sense of, do you have a lot of mummies and or do you have a lot of infested mummies with navel orangeworm larvae in your blocks? We don't have actionable thresholds or anything here, but this is a good practice to understand, of the mummies that are still out in your orchard after you've hopefully very aggressively sanitized, what is that, how many mummies are there per acre or per tree, and how many of those are infested. Egg traps, these are very useful. So you have this plastic black cylinder. There's an almond meal bait inside, almond or pistachio meal bait that attracts females that are mated to oviposit, deposit eggs onto the ridges on this container. It's kind of the size of like a small vial. So just showing you some zoomed in imagery. Here's some eggs on here. These white ones, they've already hatched. The red ones, those are still in development. So you can differentiate the stage of development of the egg, and then of course what the egg itself looks like. So you want to put these out in March or early April at a density of 1 trap every 5 acres, or that translates to 8 traps over 40 acres. Count the eggs on these 1 to 2 times per week. And after every count, you're going to want to scrub off the eggs, unless you keep a running tally for each specific trap, to see how many more are added in each sample period. You're going to want to replace the bait every 4 to 6 weeks. These are most effective during the first flight in a well-sanitized orchard. And that's because that ovipositional bait, that almond and pistachio meal that's in this trap, it's very apparent early in the season. It's kind of like smells like a new crop nut to the females when you don't have any of that available, really. But as you get later into the season, you can imagine as all these new crop nuts become available, it sort of camouflages and dilutes the attractancy of that egg trap to females. So you'll see egg trap numbers diminish significantly later in the season. That's not because the females have gone away. It's because they're ovipositing on new crop nuts rather than this egg trap. But the egg trap is critical. It's very, very useful for determining your biofix, which you then plug into your degree day models. And I'll explain all that here in a minute. Flight traps. So there's different types of flight traps. These are to monitor navel orangeworm adults. You have wing traps, kind of these 2 parallel square pieces, and you have delta traps, more of a triangular shape. They come in different manufacturers, different colors. They're kind of all good, whatever works for you. You have within these different lures that you can utilize. There's pheromone lures. So this is a lure that will attract male navel orangeworm. It's a synthetic analog of that female pheromone. You have ovipositional baits. So this is similar to the egg trap, an almond and pistachio meal bait that attracts mated females. And then the PPO lures I mentioned that attract both males and females and are highly useful in a mating disruption situation. So these traps have sticky liners here. You can see that, and there's a sticky liner insert there. And the moth goes to the lure, gets stuck on the liner, and then you can count how many moths you get per week or whatever your sampling frequency is. I just want to use this moment to highlight a key thing to understand. These pheromone lures, or that are sold as lures for flight traps, like I said, they're attractive to males. It's like the female pheromone sheep. The males pick it up, they follow it just like they do a plume, and that's how you get them into the trap. mating disruption, which is also using a synthetic version of a key component of the pheromone of navel orangeworm. Those emitters, the puffers, the polymeric emitters, those are not attractive in and of themselves. So moths, they're both, the mating disruption and the lures are both using compounds from pheromone, but only the lures are actually attractive to males. So by putting out mating disruption in your orchard, you're not attracting more moths to the emitters or anything like that. You're simply putting out this chemical that's disrupting the male's ability to find females, whereas these lures do have, magnetism that pull, they're attractive to males. So outlined a lot of this in that last slide. The pheromone lure that attracts males, the ovipositional bait. This is sold currently by the Peterson Trap Company. We refer to it as a Peterson trap that attracts females. These, of course, remain attractive under mating disruption, although you'll probably get a similar dilution effect as new crop nuts become available and make this ovipositional bait less apparent to navel orangeworm. The PPO trap, that attracts both males and females. So pheromone trap, you're going to get basically just navel orangeworm males on your liners. A Peterson trap, you're going to get just females for the most part on your liners. And then the PPO trap, it's kind of a blend of males and females. Timing and use of these traps, you want to set them out in March or early April, 1 trap per 10 acres or a minimum of 2 traps per block. Hang them somewhere that's unobstructed by foliage. Check them weekly, replace the liners every 1 to 2 weeks, and replace the baits every 4 to 6 weeks. Early split nuts. So like I mentioned earlier, this provides an opportunity for navel orangeworm to get an early start. You want to look for these in mid to late July in your orchard and consider a treatment if there's more than 2 early splits per 100 nuts. And I'll talk a little bit more about spray timing here when we get into the chemical control section. So biofix and degree days, I mentioned this earlier. Biofix is the start date for the development of the insect, and that's determined by trap catch in your egg traps here. Degree days are calculated based on these lower and upper developmental thresholds. I mentioned that temperature drives development of these insects. So the lower and upper thresholds are the range of temperatures within which an insect will develop. So this graphic down here is just showing you, here's your lower threshold, here's the upper, here's your daily temperature fluctuations. And the way we calculate degree days is finding this kind of area under the curve within these 2 thresholds to add up the number of degree days for a given period of time. So degree days, it's a unit of measure to track the rate of insect development. And technically speaking, 1 degree day is 24 hours at 1 degree above the lower threshold of an organism. So navel orangeworm lower and upper is 55 and 94. The degree day requirements, 1050 degree days Fahrenheit between egg deposition periods. So that's generation to generation. And then 2100 to go from the first to the third egg deposition period. That's just doubling this first one here. Your biofix for navel orangeworm is determined by egg trap data. You're going to identify this during the first peak egg deposition period. And then you can plug this in, this date, and then look at temperature information after that date to look at the summation of degree days. So this is showing you your kind of what egg traps data would look like over the course of the season. You can see it's slowly getting lower. Again, not because the population is getting lower, but because the attractancy is declining. But here's these degree day periods from your first egg laying peak to your second, and so on. This is showing you flight trap data on top of that, and it's kind of an inverse relationship. So the flight traps, they remain attractive over the course of the season, and the population, of course, grows over the course of the season. So you'll see this egg trap data declining as the apparency of those traps declines, and then you'll see these populations of adults in the flight traps kind of exponentially growing in the other direction over the course of the season. So this is just showing you screenshots from the UCIPM website. We have a tool that you can use to calculate degree day accumulation for navel orangeworm. You have the website down here at the bottom of the slide. You go in there, you pick your county, you set your biofix. You can put in the date that's based on that egg trap data, and there's details on the UCIPM website how to set that biofix using egg traps. It's essentially when you see the first peak egg laying period by the trap data. And then you put in your start date, the biofix, your end date. Then you go to the next stage, you hit continue. Oops, sorry. So hit continue down here, go to the next stage, and it's going to say, okay, you're in Fresno County, select your weather station. And so you select the one that's closest to where you're located. In my case, I put Kearney Ag Center. You can see it there in red. And then it'll bring you to the next screen. It says, okay, you got Kearney Ag Center. Here's your biofix date. This is a model for navel orangeworm and pistachio. And you go ahead and hit calculate. And that's going to spit out this chart showing you the minimum and maximum air temperature for that day, for each day. And then it's going to show you the number of degree days that were accrued in that day. And then you have a running total of the total accumulated degree days here on the right. And so I'd scroll down on that page and get all the way down here to here's 10,000 or 1,050, somewhere right between these two dates, June 20th and June 21st. So that should be day estimations. That should be the initiation of the second egg laying period. Now, what you want to do is then compare that to what you're seeing in your egg traps and your flight traps. And you can keep running these models as the season progresses to see how your trapping data lines up with what the temperature data is telling you in terms of estimating the phenology of this insect. Okay, spray timing. So timing of your sprays is really this intersection between the phenology of the insect and the crop itself. So degradation of hull integrity that leads to your crop vulnerability. And so your spray timing should be based on insect phenology. You're getting that through your monitoring data, the crop phenology, you're looking at hull integrity, and then of course your relevant relative pressure that you're seeing that year. The current products that we have for navel orangeworm control, primarily you have methoxyfenazide, Intrepid, chlorantraniliprole, Altacor, multiple pyrethroids, and then spinettaram in the trade name here, Delegate. Just a few things to point out here that's important. The program that we're recommending is spray with Intrepid and Altacor primarily. Pyrethroids, these have been around longer. We are seeing some navel orangeworm resistance to one of them, bifenthrin, one of the key ones. So there's going to be issues with this group down the road. There's also more negative environmental impacts associated with pyrethroids compared to these other two. Just listing here, kill beneficial parasitoids and predators, offsite movement into waterways, potential for regulation, or via resistance, potential for self-regulation, and it won't work on the navel orangeworm anymore. Delegate, a fungal fermentation product, contact and ingestion toxin. You have Intrepid Edge. It's a combination of methoxyfenazide and spinettaram. So more on rates and all of that on the UCIPM website, but just showing you broadly the different products that are out there. So this table, again, thanks to David for sending this my way, really nice summary of your different potential spray timings and the priorities for them. So with navel orangeworm and pistachio, third flight, spraying in early to mid-August, right when hull slip is occurring, that is critical. That is the time to spray for this insect. If you're going to spray one time per year, this is the one. And effectively all orchards need a treatment. This is kind of approximately 4 weeks ahead of harvest. If you're going to put on a second spray, it's kind of a tie here between spraying earlier in the season. If you're seeing a lot of early splits, that's preventing that second flight from really getting a foothold in the orchard. Because if you have a lot of splits, if you have moths in there and you don't get aggressive about them, then it's really going to blow up on you in this third flight. But in the absence of that, a second spray a few weeks after that first one in early August, so this is kind of a late August to early September spray, to maintain your insecticide residues on holes, again, based on flights, if it's in pressure in the current year. So if you've got a lot of pressure, you feel the need to do that, that's where that would come in. These other spray timings earlier in the year, first flight, second flight, theoretically preventing oviposition on the mummies. There's really no ideal application date for that. The efficacy is undocumented, and you have potential for disruption of other beneficial insects like Phytochorus. And then again here later in this, a fourth flight spray, again in a really late harvest, super high pressure situation. But again, the focus here, this third flight spray, and then these two sprays around either side of that. Really nice data here from David showing the efficacy of these sprays. This is just showing that basically all these different products, they are effective. relative to not spraying. But it's not a linear relationship between the number of sprays and the amount of reduction in crop damage. So one application, we typically say that has about a 50% reduction in damage. The second spray, you're getting now 65%. The third spray, 75%. There's kind of a declining return on each additional spray. So in some cases, at some point, more is not necessarily better here. For any spray, again, talk to your farm advisor, look at the UCIPM website. You want to make sure your sprayer is calibrated, you're going slow, you're doing it in the right weather conditions, just like you would for any other product you're putting out in your orchard. There are training opportunities available around spray operations. Finally, early and timely harvest. Like I said, navel orange populations build exponentially over the year. The longer the crop hangs on the tree, the higher probability of infest. Higher infest, a problem this year means you're gonna have more infested mummies the following year. So a late first shake, begets a late second shake. This is data, again, shared from David Haviland, showing that the percentage damage to split in-shell pistachios, exponentially increasing as we get later into the year. Here's your degree days. I showed you how to calculate those. So the longer that crop is out there, the more they're getting hit. And this is some really cool data from Brad Higbee and David Haviland as well, showing the total load count. So that's kind of the amount of crop coming in. And you're looking at the timing of that crop coming in. And then here's your insect infest averages. And then here's your maximum. And you can see here the September 15th period, you really are starting to get things taking off. Where it's bad, it can start getting really bad. And then you can see this infest kind of rising here towards the second or the last kind of third of September. So again, the sooner you can get things out of there, the sooner you can avoid this happening. So if your first shake is here, then your next shake's here, okay, you've kind of avoided a lot of that. But if your first shake is here, and then that means your second shake's going to be over here, then you're in this red zone. So again, just the importance of getting crop out of the field in a timely manner. Okay, so where do I even begin? This is a ton of information. It's a lot of different strategies. You're trying to, I can tell you all this stuff, but then it's on you to integrate all of it in your operations, which is certainly can be an overwhelming process. The key here is to just hit them in as many places as possible. Like I said, there's not a perfect strategy that trumps all the other ones. So I just put this together. Here's your figure of their developmental kind of phenology over the course of the year and the points of intervention for each one of these different strategies. So crop sanitation, hit them in the fall, hit them over the winter, get the mummies out of there. Mating disruption, you have that up and running in the spring all through the summer. So every time that you have a flight, they're having difficulty finding each other. So you kill all these ones through sanitation. The few that survive, you're making it hard as possible for them to find each other and successfully mate. Those few that find each other and successfully mate and make it to the third flight, boom, you hit them with insecticide. And then those few that even survive that are still trying to get, or the fourth flight that's coming on, you get the crop out of there to take that away from them. And then again, back into the sanitation. So it's just like boom, 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 boom. This is kind of the ideal navel orangeworm management program. I emphasize ideal. It's just summarizing and kind of putting into a time series all the different things you need to do, from crop sanitation to monitoring through sprays and harvest. So I'll let you just look at that on your own. So closing thoughts here, crop sanitation, it is fundamental. You must do it. In a bad year, no amount of spraying can replace the impact of crop sanitation. A lot of this is logistics and planning. It's fundamental. You should develop a monitoring plan and stick with it. And it requires you to coordinate equipment and crews and keep an eye on the weather and crop phenology and all that stuff. The number of treatments, the treatment timing, the product choice, there's all these different factors that go into how you determine that. And again, just listing all of these things here, there's no perfect system, but these are, as a grower, really important questions for you to keep in mind to bring up with your PCA when they're coming to you with a recommendation, and thinking about, what you've observed year over year in your orchard. What did mummy assessments look like last year relative to infest? How did mating disruption work? What about this spray timing? How did our monitoring work? How closely did the biofix and degree day models, how accurately did they predict what we saw with the third flight? So just a lot of different things to think about. again, resources available to help you make these decisions, your local farm advisor, your IPM advisor, the statewide IPM program website, and of course the Pistachio production manual. With that, I've got my contact info here, my website, my email. I appreciate the time and opportunity to share this info with y'all, and wish everyone the best of luck out there. Thanks so much.
All right, let's get that quiz question up. Houston, I'm not sure we're going to have any time to answer questions. So if you don't mind hanging around a little bit, you can actually type in answers in the question and answer section.
Okay, just while we keep going, that's fine.
Yeah.
Happy to do so.
You should see the poll now up on your screen. There are 3 questions, so make sure you scroll through and submit your answers. We're going to give you about a minute here, and then Houston, I'll just ask you to spend like 30 seconds briefly going over the answers, especially if the majority of people seem to not get it correct. That'll be what to concentrate on. And again, make sure you respond to these questions, and then these questions will be on a quiz that is emailed to you after, and you only have to take that quiz if you want DPR credit. So go ahead and answer. We'll give you another 30 seconds to answer. So Houston, if you could just take a minute and kind of go over them.
Oh yeah, very good students. Okay, y'all basically all got an A. Yeah, which of the following activities are important for management of navel orangeworm? Sanitation, monitoring, early and timely harvest, well-timed sprays. The answer was all of the above, right? So again, there's no one tool that's perfect. So you got to do all of that stuff. Those of you that did answer sanitation, there was some percentage there. That is definitely the most important tool, but should not be done to the exclusion of all the other tools. What mediates navel orangeworm ability to attack new crop nuts? Whole integrity. That was the answer we were looking for. That's what most of you responded. Moth abundance means you probably have a higher probability of having some infestation. Warmer temperatures drive the development of population. Total crop load, I guess there's more nuts there to attack, but the ability of them to actually get into that new crop nut is mediated by whole integrity. So if you have an intact hull, very difficult, close to impossible for them to get in. Once you get whole split or whole slip, then they're able to start getting in there. And then finally, what are some additional resources to help you manage navel orangeworm? I hope I drove this home. Local farm advisor, IPM advisor, UC IPM website, and the Pistachio production manual, all of that. The answer was all of the above. So
Great.
cool.
Thank you so much, Houston. All right, our next talk before the break is by Themis Michaelides, who is a plant pathologist with UC Davis, also based at the Kearney Ag Center. And he's going to be going over aflatoxin and its biocontrol in pistachios.
All right, thank you very much. And thank you everyone who is attending this course. This morning, I'm going to present the aflatoxin and its control in pistachios. And I'm really glad that Houston talk was just before this talk, because navel orangeworm is really an important issue and risk factor for the aflatoxin contamination in pistachios. So first of all, let's decide what is the aflatoxin. What is the definition of aflatoxin? Aflatoxins are toxins, as the name indicates, that produced by fungi, the Aspergillus flavus and Parasiticus. And the myco stands for mykis in Greek. That is the translation for fungus. So the two fungi that produce aflatoxins is Aspergillus flavus and Parasiticus, and we have a group of aflatoxins produced by Aspergillus flavus. We have the B1 and B2 based on the blue fluorescence they emit under the UV light, and also the Aspergillus Parasiticus produces two additional aflatoxins, the G1 and G2, that show, in addition to B1 and B2, they show green fluorescence under the UV light. The M1 is aflatoxin that can be detected in milk. Why are we studying aflatoxins? If you see this chart here from a survey of the rapid alerts from EU, you will notice that the maximum percent for rejections of loads is because of the aflatoxin. And the second in order is the ochratoxin. You can see in this graph that among the mycotoxins that are detected in the alerts, the aflatoxins account for 50 up to 75% of the mycotoxins detected. So, and that is the reason the California pistachio industry has taken very extensive measures and supported research and still supports research to control the aflatoxins and to assure that the compliance with the domestic and foreign regulations. So the aflatoxins are regulated very strictly, and here are the limits, the tolerances for pistachios for direct consumption. We'll have in the USA for total aflatoxins 15 parts per billion, and for aflatoxin B1 10 parts per billion. The aflatoxin B1 is regulated separately because it's the most potent aflatoxin. In Europe, they're even more strict. And you can see here, we have for total aflatoxins 10 parts per billion, and for B1, 8 parts per billion. And recently, there are talks even to reduce these tolerances even more for total aflatoxins 5 parts per billion and aflatoxin B1 for 2 parts per billion, which will make the marketing even harder and the issue to clean the nuts from aflatoxin even harder. So there are several crops that are contaminated with aflatoxins, and these crops can be separated into two different categories. We have the ones that are contaminated with high risk, and this will be corn, peanut, and cottonseed. And the ones that are occasionally contaminated, and this will include tree nuts, figs, sorghum, spices, and others. And as you can see, the pistachios belong in the occasionally contaminated crops, but still, because it is a value crop and is exported and we have strict tolerances, still have the issues with the aflatoxin. In this course this morning, I'm going to give you information about the fungi that produce the aflatoxins, what really causes the aflatoxins, the fungal variability and how we use this fungal variability to develop a control approach for aflatoxin, the various risk factors for aflatoxin contamination. And I emphasize the pre-harvest, the aflatoxin contamination that occurs in the field, because that's the most difficult to control. And then defects that are associated with contamination and what we do to reduce these defects. And finally, the only method that we have as a treatment, which is the biocontrol of aflatoxin. And starting with the two pathogens that cause aflatoxin is the Aspergillus flavus and Aspergillus parasiticus, as I have said. And you can see these are very common in our orchards. The color of these fungi here in these cultures is because they produce abundant spores, conidia, which become airborne, and these airborne spores can contaminate the soil and the atmosphere in the orchards and can reach the nuts to infect the pistachios. In addition to this type of spores, these fungi, and particularly the Aspergillus flavus, produces these black structures here, which we call them sclerotia. And based on the size of this sclerotia, we have strains that produce large sclerotia, and they are named L strains. And we have strains that produce small sclerotia, and those are called S strains. The difference between the two is that the S strains, most of the S strains, even close to 100%, they produce aflatoxin, while the L strain, we have about 50-50 populations in the orchards, that 50% can be toxigenic, producing aflatoxin, and 50% not producing aflatoxin. And this is the first shot we get here, using one of these strains to develop a biocontrol and toxigenic strain that you will see at the end of this talk. Now, the density of this fungi, Aspergillus flavus and parasiticus in California pistachio orchards varies from few to about 25 to 35. And these are very low densities in comparison with the other crops that are really have high risks of contamination, like peanuts, cotton, and corn, where the density of the spores in those soils is up to a few thousands. So in a way, we have few colonies, few propagules of these fungi in California soils, but still we do have problems with aflatoxin in our crops, pistachios, almonds, some walnuts, and figs. This graph here shows you the life cycle. These fungi live in soil, and they attack debris, can behave like saprophytic secondary parasites, secondary organisms, can attack debris and produce spores as the green spores, which become airborne. And these spores can go into the tree canopy and infect the naturally wounded pistachios, as well the pistachios that are wounded, damaged by navel orangeworm. And you will see that the navel orangeworm not only wounds the pistachio, but also it is an active carrier of a vector of the propagules of Aspergillus fungi that produce aflatoxin. Later in the season, we have the mummies on the trees, and we found that when we evaluated mummies, about 2% of these mummies will have infection with Aspergillus flavus or parasiticus sporulating, and when these mummies reach the soil, they can enrich the soil with spores, and also in that way can close the life cycle of these pathogens in pistachios. Very similar, it's in the almonds. The same similar, is very similar life cycle. So there are several pre-harvest risk factors that really affect aflatoxin contamination in pistachios, and they are listed here. And the navel orangeworm is, I will say, the number one. Then we have the harvest date, the early splits, and we have ways now to affect early splits with cultural practices or with stock. The location where the orchard is located, we have locations where we have hot spots. The year, if a year is on and off, that has an effect in the levels of aflatoxins, and also the levels of various defects on the nuts, like early splits, stained nuts, or damage by other means, etc. So we showed that the navel orangeworm is really very detrimental, is a major risk factor for aflatoxin contamination, and the increase in the damage also results in higher levels of aflatoxin contamination, as you can see here. And once you get more than 2% damage, you can see the levels of the positive with aflatoxin have increased. In addition, the samples we analyze with high levels of amounts of aflatoxins, 10 parts per billion and 100 parts per billion, are very, very high once you get the higher than 2% damage by navel orangeworm. So here's a study that also we showed that there is a relationship between the wounding The feeding sites, for instance, the navel orangeworm can do on a nut, and this was done with almonds, and there is a direct correlation between the feeding sites and the aflatoxin amounts, as shown here in this graph. Not only there is a relationship with the feeding sites, the damage by the navel orangeworm, the wounding of the nuts, but also we show that when we trap with sticky traps, for instance, in this case, a navel orangeworm moths, and we plate them in media selective for Aspergillus fungi, we find very high levels of Aspergillus flavus and occasionally Parasiticus. Now, you can see in this graph that when, and these are actually moths that we got from Dr. Siegel from USDA across the street, you can see that even the moths that were emerged early in the season, in March or in April, from mummies that overwinter, even those can have certain levels of Aspergillus flavus. But later in the season, the moths that we trap in the orchard, because there is a lot of contamination with soil dust and the propagus in the air, we have very high levels of Aspergillus flavus occurring on those moths. So we have a case here where the navel orangeworm not only increases the aflatoxin contamination with the wounding, but also contributes to spreading the inoculum from nut to nut. Now, the second risk factor, which relates also with the damage with the navel orangeworm, is the delay in harvest. If we delay harvest, the delayed harvest increases navel orangeworm infestation. And we show this also experimentally. By delaying harvest about 20 days here or 30 days here, you can, we increase in the nuts we evaluated about 6 times here and about 7 times here, the damage by navel orangeworm. And of course, this is a graph that really actually shows the what happens in nature. These are the loads that were evaluated by Joel Siegel of USDA. And in essence, he showed something very similar in a way. He showed that the damage you have after the first week, counting after the 21st of August, the damage can be doubled after the 3rd week of harvest. So we have an exponential increase of the damage after 21st of August, regarding if you move from the 1st week and delay the harvest 2 weeks later. So in experimentally also we did this, and we evaluated samples that were, and these are library samples that were harvested before 14th of September. And then we separated groups 14 to 22 September and later, later than 22 of September. And then we have the reshakes. As you imagine, the reshakes, because they're very late, they have very high levels of positive samples of aflatoxin and very high levels of incidence of samples with large amounts of aflatoxin exceeding the 10 parts per billion and exceeding the 100% 100 parts per billion. But if you compare the 3 samples here, you can see that positive from the samples here were doubled with 2 weeks late, 1 week later. You can see here the positive amount was doubled. And here the samples with more than 10 parts per billion was doubled 1 week later. And the samples with more than 100 parts per billion were doubled here. So which also indicates the importance of harvesting the nuts on time and as soon as possible after they mature. So recommendations here from these studies, of course, the control of I cannot emphasize more than reducing damage by now. It's very important. And I will follow, and you can follow what the entomologist suggests with the sprays, with all these procedures that Houston outlined in his nice talk. And also decrease the number of mummies left after harvest. The sanitation, as we say, shake the trees to remove the mummies, blow them off from the berms, and do this annually in order to reduce the mummies, do good sanitation, and do not delay harvest. This is a good picture of showing a good sanitation here. The trees are not very large, but still there are a lot of mummies left, and this grower shook the trees and blew off the nuts from the berms, and then he shred them in the middle here in order to destroy them. This third factor is the early splits. Early splits are nuts that split prematurely, expose the kernel, the shell splits and expose the kernel to insect infestation, mainly by navel orangeworm, and to fungal infection. The early splits is one of the main sources also of aflatoxin contamination in pistachio nuts, and I consider this as the Achilles heel for aflatoxin contamination. Now, it is fortunate that some of this, the majority of these early splits will develop a very distinct suture, and this is something the processing plants have to pay a lot of attention and remove those nuts. And in fact, they do a lot of color sorting to remove stain nuts, and also particular sorting to remove the suture staining. In an experiment to show you how important these early splits are in aflatoxin, we did collect the samples, and we separated them in those that have shriveled hulls and those which have small smooth hulls, and also normal nuts. And then we had multiple samples. We analyzed them for aflatoxin. You can see here the aflatoxin, how much aflatoxin how much of the aflatoxin can be explained with those that have the shriveled hulls. It's almost, most of the aflatoxins are located in those hulls, the early splits with shriveled hulls, and also a little amounts in those with smooth hulls, which are the early splits that develop close to harvest. Now, if you combine these with the navel orangeworm damage, that will give us the 100%, the aflatoxin. That will explain the 100% aflatoxin. This was done for 2 years. The incidence of early splits, we recorded the early splits in various orchards, and we found it can vary from orchard to orchard. It can have less than 1% up to 5–6% in some orchards. And this was an indication to us, perhaps there is a way to reduce the early splits, the incidence of early splits. And so in order to reduce the incidence of early splits, we noticed initially that orchards that had some stress for water had more early splits, and we designed this experiment where we found that the irrigation has a very important role in the amounts of early splits. In fact, in these two orchards, A and B, we skipped one irrigation in May, a critical irrigation that is very detrimental for the affecting the size of the shell. And we, in fact, at the end, when we evaluated the early splits, we found out that if we skip this irrigation, we increased the early splits almost double here. So it is very important to supply sufficient irrigation during spring to avoid the tree stress in order to reduce the early splits. The other thing that we noticed was that in some indications that rootstock has an effect. And we were lucky enough because Louis Ferguson and Craig Carlson had some plots with different rootstocks, Pistachio atlantica, UCB1, the PG1, PG2, and on top they had the Kerman variety. And we did evaluations of early splits, and we found that indeed in all these 4 locations, the PG1 and the Pioneer Gold and the UCB1 are the ones that resulted in lower early splits in comparison with the old rootstock Atlantica, which had the most of the early splits. And also you can see that the location has played a role here in Kern County. We didn't get a lot of early splits. Now, so then recommendation comes from here is to use a rootstock that minimizes early split nuts. Now, a fourth factor that really affects it's a risk factor affecting the aflatoxin contamination is the location. So we found by analyzing a lot of library samples that there are some locations where the samples are loaded with aflatoxin, and we found Fresno, Madera, and Merced are the hot spots for aflatoxin, while counties like Kern, Kings, Northern California had very low or zero. In fact, this is very true, and we show the same effect on almonds in Northern California, pistachios, and almonds in our samples never showed any aflatoxin contamination. The fifth factor is the effect of the year. If we have an on versus off year example, we have here, we analyze library samples from off and on years, and we found that when we have an on year, the levels of positives are very low, and also the amounts of the aflatoxin are very low. But in off years, we can see that we have a higher incidence of aflatoxin, more than, and also the amounts of aflatoxin be higher in those years. And this, in a way, makes sense because in off years we have less crop, and there is more competition by the navel orange worm to find the nuts and produce cause damage. And also in off years, we found that the infections is in off years, we have 1 nut out of 5,000 nuts with aflatoxin, while when the competition is not so big, when we have a lot of loads of nuts in the fields, then we have 1 nut out of 20,000 nuts in on years with aflatoxin. So the on and off year plays a role, and these are the numbers we got. The sixth factor here is the various defects. The early splits, as I mentioned, and the stain nuts are defective nuts. And fortunately, there is automated machinery now that can remove a lot of these nuts. And particularly the suture staining is a very characteristic for the early split. And another nut that is very important for the aflatoxin contamination and has to be removed as much as possible is this damage by other means nut, DBOM as we call it. We found out that these nuts are very highly susceptible to Aspergillus flavus and have high levels of aflatoxin. In fact, when we got these samples of DBOM nuts from a processing plant, and we recorded the Aspergillus flavus on them, we found there's no difference between the non-stain or yellow stain nuts. They were very highly contaminated. About 70% of them had Aspergillus flavus and high levels of aflatoxin. So to summarize here, I will skip the control of Neville orange worm. You heard a lot about this. That's very important. And one additional thing I can say here is we have to remember that to reinforce yourself to control it, because this is one major risk factor for aflatoxin contamination. Reduction of early splits, and that's very important, not to stress the crop for water in the spring, and particularly our experiment was in May. So if you skip any irrigation at that time, you have very high levels of early splits, and that's not good. And choose the right rootstock to minimize early splits, like UCB1 and PG1. So those are good. We don't know about the new rootstocks, what effects will have, but probably this is something for the new generation to investigate. Do not delay harvest and sort out the damaged and defective nuts. And of course, the industry has done an exceptionally great job in sorting out these nuts, using automated machinery, and also a lot of hand sorting to remove nuts with citrus staining, or nuts that show a frost from the Neville orange worm, and DBOM and oily. But even after doing all these procedures to eliminate all these nuts, we still have aflatoxin problems with loads that are exported and loads that are marketed domestically or abroad. So then we thought perhaps we have to investigate another approach in order to even reduce the incidence of aflatoxin contamination in the field even more, in addition to all this I reported previously. And that brings us to a treatment, which is the biocontrol by using an heteroxygenic strain of Aspergillus flavus as a biopesticide to control the aflatoxin. Heteroxygenic strain means a strain that does not produce aflatoxins. And the rationale here is to apply this strain in the field, in the soil, and when it is applied, this will multiply and increase in numbers, and then displace the toxigenic strains. Just bringing back this slide to remind you how this idea started. And here, remember that the L strain, we said that about 50% of these strains produce aflatoxins, and 50% do not. So we did an advantage of we took one of these strains, the F36 strain, that also it was selected in Arizona by USDA, and they were experimenting there with this strain in cotton, control aflatoxin in cotton seed and corn. And once we found this strain here, we thought to proceed with the biocontrol of aflatoxins in pistachios and eventually in almonds. But the interesting thing here is that when we studied the heteroxygenic strains and we characterized about 15 groups, we found out that this strain was the most frequently encountered in pistachio orchards. And in fact, this was true also in almonds, in figs, and also in the walnut soils. So although the other strains, the heteroxygenic strains, can be found in nature in less than 1%, up to sometimes 2%, you can see that this AF36 can reach up to 15% in some orchards, in soils of some orchards. This indicates that this strain is well fit for using it in the field as a biocontrol. So then almost 20 years now, we started research supported by the California pistachio industry and also the USDA. And we did initially microplots in orchards irrigated with micro sprinklers, even flood irrigated orchards. The product, the strain was inoculated on wheat. That was the inoculum that is applied. It was applied on the soil. And then we determined how much displacement of the toxigenic strains this AF36 was doing after application. What happens after application? irrigation has to happen. We have to have irrigation in order for the wheat to get wet. And then once the wheat gets wet, the fungus is activated and produces these green spores that, remember, we said these spores become airborne and enrich the soil and also can reach the environment in the pistachio orchard. So the inoculum now with the AF36 instead of wheat is sorghum. And this is produced in Arizona. The Cotton Council of Arizona is producing this inoculum because this strain was isolated first there. And I think they have the rights for the commercial use of the strain as a biopesticide. And the new product, although initially was Aspergillus flavus AF36, now it is Aspergillus flavus AF36 prevail to indicate that the carrier of the product is the sorghum. This is how the product is applied. Basically, this here goes up and down the roads and applies the inoculum under the tree canopy where the drip irrigation will make the soil wet. And the application rate is 10 pounds per acre. It's 11.2 kilograms per hectare. And the label indicates that the best time, the timing can be from late May to early July. In experiments, we show that the best population of the product occurs in early July, but because of the large acreage and because of the logistics, how to apply all this acreage with this product, the label is more from late May to early July. So when we try to do this commercially, of course, here I have to acknowledge the wonderful orchards. They did a wonderful, really, job to help us with these experiments where we had to treat 3,000 acres of pistachios with this AF36 and 3,000 acres of pistachios as controls and compare. So from this graph here shows the soils that we collected from the treated orchards. You can see that after the first application here, we have a buildup of this strain, the F36, and we reach about 90 to 95% by 2011. So this strain displays the toxigenic strains and changed the population in the soil by displacing the toxigenics. And we know now from these experiments and other experiments that the full potential for this biopesticide is when we get 95% displacement. So let me show you here in a graphic how it works. In a non-treated orchard, we have the toxigenic strains that will start low, very low. And in the middle of the season, they will start increasing the risk for aflatoxin. In a treated orchard where we apply the material, although the toxigenic strains decrease, this material then will displace the toxigenic strains and convert to green, to good fungus, the F36, that does not produce aflatoxin. And in fact, a comparison of these two types of orchards, if we compare the amounts of the propagules, we did not change the amount, we just changed the ratio of toxigenic to atoxigenic. When we did these experiments in order to get the registration of the strain, we analyzed a lot of library samples provided by wonderful orchards of the treated versus in the untreated orchards. And these were organized, and here as an average, we have 4 years average, we had a 40% reduction in positive samples by treating with the F36. That was first and second harvest. If you compare only the second harvest, where you expect higher levels of aflatoxin, this reduction, the average of the reduction was 55% by, as you can see here, the first year here we didn't have no samples. And this is from the second harvest, but this is the average of 3 years. So we can reach about 55% reduction by applying the F-36. And this was raised in 2012. It was adapted really well by the industry. As you can see here, we have now with the F-36 Prevail, the new product, more than 200,000 acres are treated. And this is because the processing plant give an incentive to the growers to treat the crop with the F-36. Now, what do we notice though in the last 8 years or so, from 90 to 95% displacement, we have a displacement. We continue these applications and we collected the soils. We have a displacement that is reduced significantly. Now the reduction of displacement is only 50 to 70%, as you can see here over the years. We also notice that after 2011, we have some years where we did not accomplish any reduction in aflatoxins, but in other years we had very significant reduction of aflatoxins, 2013 and 2015. And then after 2016, we see very low levels of reduction in positive samples after treating with F-36. We try then to explain what is going on. And the explanation, of course, may be very complex or we don't know all the details. But one thing we found out is that at least we know that when we use sorghum, this graph shows the sporulation of the sorghum in comparison with the sporulation of the wheat inoculum. There is a delay of about a week in the sporulation, in the sporulating seeds that were applied in the field. So this reduction, I think, is very significant. And of course, this reduction can make exposes the seeds to predation by insects, birds, and rodents. And predation of seeds means that we have less inoculum remaining in the field. And of course, less inoculum in the field, we have less propagules, and probably this will explain the lower displacement of the toxigenic fungi in the orchards. But fortunately, at this time, about 2 years ago, in fact, there was another product that was brought to us, and this product is produced by Syngenta. Is not registered in California yet, but all the research has been done, and we're ready to probably register next year. I'm not sure, maybe this year, or in 2011 or 2021 or 2022. One thing that is very promising with this strain, and this graph actually shows the sporulation. This strain sporulates very well under drier conditions and under lower conditions. If you compare the two lines, let's see. The two lines, the solid lines are the Aflagard. The name of this product is Aflagard. It's a different strain that does not produce toxin. The two solid lines are the Aflagard. You can see under 30 degrees and 35. They sporulate really well. And this is the percent moisture, the saturation point of the soil here. This is on soil, applied on soil. You can see that we have much higher sporulation, not only on the saturation point, but also in lower moisture of the soil. So the strain seems to be more adapted for our climate here, for orchard environment, where we have lower humidity, lower soil water content, and higher temperatures. Here's the visual appearance of this sporulation, and this is at 15. You can sporulate even better at lower temperatures. So you can see that after 4 days, the seeds with the Aflagard are covered with sporulation. The seeds with the F-36 still just starting, but they don't have sporulation. Another thing I have to mention here, and this probably also the substrate here is barley, and perhaps that may also contribute to the faster sporulation in comparison with the sorghum. Other things I have been doing now recently, we're trying to, increase the displacement in the orchards. We also try higher levels of application, higher rate of application, more than 10 pounds per acre. And also we're trying to apply the strain directly on the canopy, either alone or in combination with different additives that like Saurant, kaolin, or other polymers. So the strains can be stick onto the nuts and be there at the site where maybe wounding by the navel orangeworm may occur. Other things, yes.
You have about a minute left.
Yes, I'm close to finish here. The other thing that we're trying now, we believe that these treatments should be area-wide. And we started doing area-wide treatments. Here we have area 1 and area 2. In this area, the almond pistachio were treated. In this area, only the pistachio was treated. And the red bars here indicate the toxigenic strains. You can see these bars here are lower than the bars here, which means that the area-wide approach will reduce the toxigenic strains even more. And also this graph indicates that displacement is higher when we have a large areas treated with the F36. In summary, what we have here is the aflatoxin contamination risk in treat nuts. Depends on the host, in this case, the pistachio. We cannot change the pistachio, but what we can do is to choose the right rootstock, at least to reduce early splits, avoid tree stress with irrigation. We can control the navel orangeworm with sanitation, insecticide sprays, and other methods. The environment, we cannot change that. And we can change that, the agent. We can bring the atoxigenic, remove the toxigenic, and that way can reduce the aflatoxins. There are several sites where there is information. There is a video showing how to apply this atoxigenic strain. Bob Eady and Bob Klein are the two that presented this. And the link is shown here. And the two distributors that I know that provide the material and also have the service to apply the material. I would like to thank the California Pistachio Research Board, the California ARS, the USDA, the Department of Food and Agriculture, a lot of cooperators from here in my lab, and also the USDA in Arizona. And of course, I should not forget the processing plant, and particularly the wonderful orchards that have done so much for this research. The Seton farms, Nichols farms, Skinner farms, and of course, a lot of pistachio growers. And thank you for your attention for these presentations. Thank you.
Thank you, Thamus. So why don't we put that poll question up? We have a little bit more time, but if you don't mind, Thamus, after going over the correct answers for the poll, you could answer some questions during the break.
Oh, sure, yeah. Okay.
So you should see a poll up right now. Participants, there are again 3 questions, so make sure you scroll down and go ahead and start answering them now. We'll give you about a minute and then we'll go over the answers, and then we will take some time into the break to have questions answered. If you do not need to take the poll and you do not want to stick around for Q&A, this is a break time. We will get started again at 11 a.m.
Okay, stressing the trees for water in early spring increases early splits and aflatoxin risk. Very good answers. Yeah, that's great. Great. And of course, people understand why stressing the trees at that time is very important. If you stress the trees at the time when the shell size develops, we develop a smaller size shell. And then if you go back to normal irrigation, the kernel develop normally and will encounter a smaller shell, and with pressure will try to split this shell to develop the early split. So that is why this is very critical. What is the most critical factor that increases the risk for aflatoxin contamination? I think the answer here will be navel orangeworm. I will agree that that's really, I would say, number one. Delaying harvest as second, yeah, I will say that. Third, early splits. So all the pistachio orchards have the pathogen that cause aflatoxin. True or false? It is true that we can find this fungi in different levels in all pistachio orchards. Even in the orchards where we don't have aflatoxin in Northern California, we can detect the Aspergillus parasiticus and Aspergillus flavus. So.
All right. So I will start reading some questions from the audience. Why is aflatoxin acceptance amounts lower in the EU than the US? Does it make a difference? And does the industry set the threshold, or is it a government organization?
It's the government organizations that the EU are very strict. And as you know, they have not only strict rules for aflatoxin, but all the other kinds of GMOs and things like that, very strict. So.
All right. What are the ideal conditions for fungus to thrive and reproduce aflatoxins?
The ideal conditions will be temperatures above 20 degrees Celsius, and water activity 0.64.
Okay. In double drip line irrigated orchards, how effective is AF36? Does it need to be applied in the zone of moisture to be effective?
It has to be applied in the zone that is wet, because if the seed lands on dry land, nothing will happen, and perhaps it will disappear within a short time, maybe by ants or by birds, or if it stays there, it will not sporulate. It's very important that the irrigation, in fact, some growers now pre-irrigate, they make the soil wet and they apply the material.
All right. Have you seen any benefit to starting AF36 applications on younger orchards prior to bearing, like a year or so before the first crop?
I would say not the first year, but probably before the first crop, the first shake of the orchard, if they go 1 year ahead and start the application in order to build up the toxigenic strains. You saw in one graph that it takes a couple of years actually to reach high levels. So over at least, well, now 50 to 70%. So if you apply it earlier, you'll have, by the time you do the first harvest, you have a build-up of inoculum of atoxygenic in the soil that will be helpful.
Okay. There was a question about whether or not you could provide your email, but that question disappeared. But I don't know if you could put your email in the chat afterwards.
I added the email to it. That's why. Sorry.
Okay, no worries. Okay, so the last question is the gene that codes for the toxigenic aflatoxin genetically coded as a monoallelic trait?
There is an echo in your talking. Say that again, Phoebe.
Sorry about that. Am I still echoing?
Let me adjust this. Go ahead.
Okay, so is the gene that codes for the toxic aflatoxin genetically coded as a monoallelic trait?
I will not know. I don't know that. I do not study the genetics of these fungi, so I'm not sure.
Okay. Well, that's it. So I guess we're going to be starting up in 4 minutes. So thank you, Famous. For our last talk of the day, we have both Kent Dana and Houston Wilson giving it. So I already introduced Houston earlier. He is the entomology specialist with UC Riverside, based at the Carnegie Center. Kent Dana is an entomology specialist with Berkeley, and he's also based at the Carnegie Center. And they're going to be going over small and large bug damage in nut crops.
Thank you, Phoebe. Good morning. As Phoebe mentioned, I'll be splitting my time with Houston, and we're going to talk about small and large bugs on pistachio. And because Houston's going to close this out, I'll start by thanking the postdocs and folks that have worked on these projects with us, most importantly, Judith, Glenn, Paul, Bob, Beatty, our cooperating growers, California Pistachio Board for funding this research, along with CDFA's Specialty Crop Research Initiative. So as a brief outline, we're going to first just look at these different kinds of small and large bugs. Unlike navel orangeworm, we've got a whole medley of different insect species that look quite different from each other. We want to be able to recognize which species we've got out there in the different orchards. I'm going to look at the damage, both the seasonal biology and the economic damage. And really the controls focus on monitoring. The controls don't change very much for most of these species. It usually is well-timed pyrethroid sprays, but you want to save your money and reduce sprays by knowing what you've got, what species are out there, what their densities are, and when they're out there to improve the timing of these insecticide sprays. So we'll start with the small bugs. There's a whole variety of different small bugs. Calicoris, Phytocoris, Lygus, and Neuroculpus are usually the 4 species we most commonly think of as small bug pests in the pistachio fields. They're oftentimes associated with ground covers, but not always. They can be quite migratory, especially Lygus. So it's important to start monitoring for these fairly early in the season, because with these small bugs, it's a numbers game. They're typically most important early and become less important as the pistachio shell hardens. We also want to make sure we don't confuse small bugs with some of the beneficials that look very similar to these. We've got an anthracot and a nabbit here. These are beneficial insects. These are insects that help control navel orangeworm. These are insects that probably also feed on some of the small bug eggs and large bug egg masses. So spend some time with the UC IPM guidelines, learning what some of these different hemipteran pests and beneficials look like. Large bugs are a little bit easier to identify. We've got 2 main categories, the pentatomids, or the stink bugs, and the coreoids, the leaf-footed bugs. Houston's going to talk about the leaf-footed bugs, so I'm going to spend a little bit of time on the stink bugs and let Houston take over at about 11:30 for the leaf-footed bugs and his control program with that pest. Leaf-footed bugs are getting more attention. They typically do cause more damage because of their numbers. But the pentatomids, the stink bugs, especially some species like the chinavilla or the green stink bug, can be more consistent pests in the orchard because they can overwinter in the orchard. So here is our chinavilla or acrosternum. This is the green stink bug. There's another common green stink bug called Nazara, which is not commonly found in pistachios. There are 3 green stink bugs, not including Nazara, that can be found in the San Joaquin Valley pistachio orchards. They look somewhat similar. I like to point out on the chinavilla or the green stink bug, we've got these 5 yellow dots right on its, what we'll call its back area. There is a slight yellow margin around the edge of it as well. And these 2 features pretty much distinguish it from the other common green stink bugs. These are the other 2 stink bugs that are green that we see. There's the Say's stink bug, Euler stink bug, both are Chlorocroa species. And instead of having 5 dots on right behind its scutellum, but in that triangle back area, you've got 3 yellow dots. And the margin of yellow around the side is a little bit stronger, a little bit larger. That's what we typically use to tell the Chlorocroa species apart from the Chenevia. But also more important is these Chlorocroa are a little bit more migratory. They tend to come from outside the orchard, whereas the Chenevia, the species we saw before, is can overwinter in the orchard itself. So here we've got the Chenevia, and the last of the green stink bugs is the red-shouldered stink bug. And that's very obviously shown differently because of that red stripe across its scutellum. But I also want to point out that winter morph of the red-shouldered stink bug gets kind of brown looking in color. So that kind of is faded out. The red becomes kind of a darker brown and the body fades to kind of a light brown in color. Now you can see pictures of all of the different stages on this website called Bug Guide. Just Google Bug Guide. I actually like it quite a bit because it will have the different instars for many of these common stink bugs and leaf-footed bugs, because the instars of these stink bugs are much harder to tell apart. As an example of that, I'm going to go through the most common one, this Chenevia. Eggs are barrel-shaped. Think of 50-gallon barrels all kind of closely packed together. They've got some color to it before the stink bug first instar emerges. And then they look like just a shallow eggshell. You can see the top kind of popped open. If they're parasitized, then it's going to be a chewed hole coming out. If the parasite's still in it, it'll be a blackened egg mass. They go through all kinds of crazy color changes as they go from first to 5th instar. All the stink bugs have about, well, they all have 5 instars. This is the first instar of Chenevia, the green stink bug. They kind of cluster together. They're grouped together as a first instar. They don't disperse. Oftentimes, these stink bugs won't even feed as a first instar. They huddle together. They share symbionts that helps them survive. And then a second instar, as they start to disperse and start to feed. They go through, again, all these wild color changes. That's about a second going into a third. That looks to be a third going into a fourth instar, 5th instar. You can start to see the wing pads forming now. That's a 5th instar. And then the adult. So all kinds of crazy color changes. I also want to point out we've got this brown marmorated stink bug. It's got a blunt face. It's got whitish bands on the antenna. It's got this marginal pattern that you see around right past the wing area. This is another invasive species for California growers to deal with. It has been found in the San Joaquin Valley. It has caused damage to almond trees up in the San Joaquin County, Sacramento County, but we just haven't seen much damage here further south, Fresno, Tulare, Kings, Kern. I'll talk about that a little bit later with the amount of damage it causes. Very similar looking to the Brockamina, or the rough stink bug, which is a beneficial stink bug. Okay, a little bit about the seasonal biology and economic damage of these insects. The small bugs, again, a little bit more migratory in terms of where they are. The Phytochorus be the one that is not migratory. Lygus is very migratory, can come from weedy fields outside or inside the orchard, can build up on things like alfalfa, tomatoes, sugar beets, head into cotton beans later in the summer, and then overwinters, comes back into the spring into the orchard. For all of these insects, you really have to build up large numbers early in the season to cause damage. The Calochorus, typically it's got 1 generation per year, again, an early season damage insect. Again, you have to have large numbers to worry about. Phytocourse, as Houston mentioned, this is both a pest and a beneficial. It can switch from feeding on navel orangeworm eggs, European fruit licanium small stages, to feeding a little bit on the pistachio, but only when it's a very small BB stage. Phytocourse, unlike the others, have got many generations per year, 4 generations per year, and it can be found throughout the season on the pistachio, but really is feeding in the understory later in the season. Typically, the stink bugs have got 2 generations per year. We're saying the nymphs and adults for the brown marmorated stink bug. I want to point out here, we don't think it survives well south of Madera County because of hot July, August temperatures. When you've got the eggs for the 2nd generation hatching, the nymphs coming out, that tends to really drop the population density down. For many of these stink bugs, they're strong flyers. That's especially true for leaf-footed bug that Houston will talk about later. You've got these 2 wings. The one that's the colored pattern that you see when the wings are folded back, that's the harder wing covering, more of a protective layer. Underneath looks more like a fly wing behind that. That's the one that's really used a little bit more in flight. We know some of these things like the red-shouldered stink bug can quite fly some distance to get into the pistachio. It's the Chenevia, the green stink bug, which you commonly see overwintering. So leaf-footed bug and some of the stink bug species are a little bit more migratory. Bug damage has to do with their size, has to do with their mouth parts. So you can see here a ligus. Underneath, we can see the mouth part for that, right there. So small bugs have small mouth parts. Large bugs, that's the mouth part of a stink bug. Much larger, much thicker. What that allows them to do is to go into the pistachio later in the season. So as the pistachio shell gets harder, they can still penetrate it, causing more damage and longer periods of damage. So April and May, this is when both the small bugs and the large bugs cause damage. They feed on these BB-sized nuts, causing from the outside what you see is an epicarp lesion. Sometimes the nut just turns black and drops from the cluster. A lot of these BB-sized nuts that drop off the cluster don't really add up to season-long damage because of plant compensation. That's something Bob Beatty showed with some of the small bug work he conducted. As the load starts to set, and you can see that with some of the nuts here, we got that epicarp lesion, that fruit load is set on that pistachio cluster. This will lead to damage later in the season because that nut is now part of what's going to go to harvest. We can see here later in the season when the fruit load is really set, we've got the epicarp lesions on the outside. You can see it in both of these yellow circles. Then we look at the inside and you can see some of the kinds of damage you get. Kernel necrosis here, clean nut there, blank nut over here. Damage that we don't really know of what's happening there. We've got stigmatomycosis here, probably some of that there. So these are all of the things we have to grade, and it starts with some of these needle-like mouthpart damages. We can see here right where that feeding wound was. We took a razor, sliced off a little bit of the pistachio. We can see that little hole that went inside. Slice a little bit further. Now we can see there's where that needle-like mouthpart went in. Over here we can see the same thing. Goes inside. If the kernel is formed, then it goes into the kernel and can cause kernel necrosis. Later in the season, we can see here, this was actually leaf-footed bug damage, but we can see where the mouth parts went in 3 places on this pistachio, causing kernel necrosis. And then These mouth parts can be dirty. When the mouth part is dirty, it can either open the pistachio wound for bacteria, something like that on the leaves, or it can open it up for fungal pathogens to get inside and cause stigmatomycosis, which is what we see here. So the damage amount and the seasonal development becomes very important for how much damage you've got. So this depends on bug density. For the small bugs, it's all about bug density. You can have a little bit of Lygus, Calicoris, any of those small bugs, because there's crop compensation. They feed on the BB stage nut, the nut drops. The pistachio is going to drop nuts normally anyway. So a small number of small bugs don't amount to a lot of damage. A lot of small bugs can cause so much damage that the fruit load is too low, is lower than normal. Crop load is also important. You've got a low crop load 1 year, then a relatively moderate sized population of small or large bugs will cause more damage. Bug size, which I'll show you next, also impacts damage. The small bugs can't penetrate the shell later in the season. Small bugs feed less than large bugs. So the larger the bug, even within the same species, the more damage they're going to cause. And shell hardness is the last part of this equation. The harder the shell, the harder it is for the small bug to penetrate. So after about June, they really can't cause damage. And it becomes even harder for the large bugs to penetrate and cause damage. So let's look at this. We've got here dropped nuts in the top graph, epicarp lesions in the bottom graph. There's the control, very few naturally dropped nuts. Red-shouldered stink bug, a small nymph. Red-shouldered large nymph. Red-shouldered stink bug, adult. And we can see an increase in amount of damage as the bug size got larger. Same thing with epicarp lesions, more epicarp lesion as the bug size got larger. So let's take that equation and compare it with plant compensation. We can see here the nuts per cluster naturally dropping down to about 18, which is when you get the fruit set. That was happening around June 1st. We can see epicarp lesions going up in May. A lot of those drop off, then fewer epicarp lesions throughout the season. I also want to point out epicarp lesions are a little bit tricky. It's a good thing to follow in May and June to see how much damage, how much stink bug or small bug damage you've got in the field. But as that shell starts to change, around late June, the insects can feed and you don't see that external epicarp lesion form as readily or as quickly. Sometimes feeding damage might not show up for a good 3 or 4 weeks later, and sometimes it may not show up at all other than a pinprick, and yet you still can have some kernel necrosis inside. We showed this. This is number of epicarp lesions throughout the season. Red-shouldered stink bug, flat green stink bug, and leaf-footed bug. And then you look at the same field with kernel necrosis, and you can see back here in May and June, we weren't getting any more epicarp lesions, but we were still getting some kernel necrosis from all of these two stink bugs and leaf-footed bug as well. So it becomes a little bit hidden. After about middle of June, you can still get some kernel necrosis, even though it doesn't show up in epicarp lesions. We repeated this work with Judith, trying to follow a little bit better what's happening with the brown marmoted stink bug, Halimorphus hales, right up here. So this is in red. What we found was that with epicarp lesions, and I'm just going to point out a few things from these busy graphs, with epicarp lesion, brown marmoted stink bug did seem to be a little bit more aggressive feeder, causing more epicarp lesions. It didn't cause any more kernel necrosis. That's KN. We also saw that it didn't cause as much damage before nut drop as it did after nut drop. So it's a little bit more aggressive feeder, caused a little bit more epicarp lesion, but that didn't lead to more kernel necrosis. And of course, with all of this work, the pistachio cultivar we're looking at sometimes can impact the amount of damage caused by both small bugs and large bugs. Softer the shell, the more damage we tend to get. So last thing I want to mention about brown marmorated stink bug is that it seems to cause different damages across the state. So while some people are seeing more damage in almonds a little bit further north, we're looking at it in pistachios. And we did a cage study where we enclosed leaf-footed bug, first instars, as well as brown marmorated stink bug first instars in June, August, and late August. And what we found was that while the leaf-footed bug survived pretty well, about 50% of the leaf-footed bug eggs or first instars survived to adults in June and early August, and about 10% during our peak heat period in late August. We got very poor survival of brown marmorated stink bug. So we think that this insect might be a pest in some regions of California where it's got other sites to feed on, such as an urban area close by, such as a stone fruit or almond orchard close by, such as the tree of heaven for overwintering site. But when you've got thousands of acres of almonds and pistachios in Kern or Tulare or Fresno County, there may not be very much there for it to feed on during the hot summer months. And so its survival, we hope, is going to be lessened and it doesn't become a major pest here in California. So we know a little bit about the species we have to worry about. We know a little bit about their seasonal biology. We understand the economic injury. It has to do with their density, their size, the crop load, and the shell hardness. So when are you going to spray? This becomes critical. We want to spray when the crop is susceptible. We want to save our sprays when the crop is not susceptible, when their numbers are lower. We want to remember that we're spraying most commonly with a pyrethroid, which is also one of our common sprays for navel orangeworm. And we're worried about growing resistance of pyrethroids to navel orangeworm. So monitoring becomes key. And the problem is we still don't have great monitoring tools. And we've got multiple species of both small bugs and stink bugs and the leaf-footed bug that we're trying to consider. So we did look at the different common sampling tools for both small bugs and large bugs. It's the visual sampling, the beat sampling, the sweet sampling. What we did is we compared sweep sampling, and we see in the upper right, Paul, sweep sampling. And typically when we're considering a sweep sample, we're actually sweeping the ground vegetation. We're trying to find out what's in the orchard early in the season or as the crop is starting to develop. So what might go from the understory up above? When we think about beet sampling, we're thinking about sampling the pistachio tree itself. And we compared that to a DVAC sampling. We also compared it to an insecticide spray where we see Bob Beatty there spraying an entire pistachio tree. Then we shook those trees and looked to see what insects were in it by killing everything. What we found from this, of course, the insecticide spray killed everything. We found at this time of the year, and you can see that the time of the year we were spraying was around late May, early June. We got a lot of phytochorus and calochorus. We got some stink bugs. The sweep net, we still had some ground cover, mostly the small bugs, a lot of phytochorus and calochorus, but we did get some stink bugs. So the sweep sample can be used to look for small bugs and some stink bugs. Notice we got almost no leaf-footed bug. They don't want to go to the ground cover. They don't care about it. The DVAC was a lot of work, was not very effective. Visual sampling, we got far fewer insects, but we got a better representation. We got some phytochorus in the tree, some stink bugs, and we got leaf-footed bug. And the beet tray sampling tended to be the best, where we got more than the visual and we got a good representation, which showed phytochorus, calochorus, stink bugs, and leaf-footed bugs. So beet sampling was probably the overall best that we still have, but we're still hopeful that Jocelyn Miller will come up with some pheromone tools in the future to monitor these large bugs. And I think Houston's going to talk about that in more detail, especially leaf-footed bug. Another way to monitor for damage, monitor for these insects, is to look for damage. Remember I showed you those little BB-sized nuts when they turn black and show epicarp lesion. So this is very important in April and May to go out and look for darkened nuts. That probably is a better sampling tool to look for small densities of stink bugs or leaf-footed bugs. And remember, of course, by late June to early July, those epicarp lesions, once you've got the crop load set, may not be as evident as early in the season. So April and June are critical. I would look for both damage to the nuts, and I would use a beating tray, or I'd take a stick to bang the tree and look for leaf-footed bug flying out and away. One of the things we've been looking at this year is whether or not we can use a ground cover or a cover crop, a planted ground cover, both to keep the stink bug underneath the pistachio canopy, and also to monitor for stink bugs and some of these small bugs. We can see here a cover crop mixture on the left and just a weedy resident vegetation on the right. And these things dry down during the summer. What we see, and this is just a little bit too busy of a graph, but I'm pointing out in red where the insecticide sprays went on to the understory. And you can see in green, dark green, and light green, this was the control, just the weedy vegetation. And in dark blue and light blue, this is our seeded ground cover. And what I want to point out on July 30th and August 23rd, the two dates towards the end, we've got a lot more of the stink bugs still in the trap crop in the ground cover than we've got in the canopy in the tree. It was significant on July 30. So there's a possibility we can use these trap crops to keep the population out of the canopy where it can be sprayed and killed before it goes up and causes damage. I also want to point out, unfortunately, that in July 30, we were getting still quite a number of stink bugs in those treatments. So in conclusion, we've got lots of different large and small bug species. Small bug species are far more important early in the season. And so it's a density game. How many do you have, do you need to spray? Large bugs are early and mid-season pests for the most part. They're really important once the crop load starts to get set, because they still can use their strong, larger mouth parts to penetrate the shell, feed on the kernel, and cause some damage. Insecticides are the most reliable option, but we want to remember that combination of crop load. So early in the season, we've got compensation. Late in the season, there's less compensation. Bug size. The leaf-footed bug is bigger than the other bugs, so it causes more damage. And mid to late season shell hardening. If you've got just a few later in the season, probably not as important. Pyrethroid applications, typically from April to May, are most commonly used. These are broad spectrum materials, but note we do want to use those judiciously because of growing problems with Gill's mealybug. Pyrethroids kill off the mealybug parasitoids and navel orangeworm resistance. So again, I like the bug guide for these bug descriptions. There's a lot of good information, more than I could detail here, in Pistachio Production Manual, as well as the UCIPM guidelines. So it's 11:30. What I was going to do now is stop my share and turn this over to Houston to talk about leaf-footed bug. Hey there, Houston.
Hey, cool. Thanks.
Houston, is it okay if I post Kent's poll questions since they covered his talk and we just do them real quick while you get set up?
Sure.
Okay. I'm going to launch the poll. We're only going to give you a minute on this one, so make sure you fill it out real quick. And then Kent will go over the answers real quick and then we'll move on. This is a check-in to make sure that you are paying attention for those CPR credits. Again, another 50 seconds to better start voting. And there's 3 questions, so make sure you scroll down.
I took the test too.
What's your score?
I get really nervous.
If you could just go over them real quick.
Okay, small bugs are really more important early in the season because their mouth parts aren't strong enough later in the season to penetrate the nut shell. The large bugs become more important as the shell becomes harder. Compensation of early season damage. That's typically that the plant will drop off a number of nuts early in the season, and it will tend to drop off the nuts that have been damaged. So it saves the nuts that are not damaged. I wish it were a government program. Large bugs are more serious than small bugs because larger mouth parts. Bigger insects, they feed more. Thank you all.
Okay. Are we turning it over here to me? Okay. All right, cool. Thank you, Kent, for the good introduction and overview. That kind of makes my job a little bit easier. And this is a much more quick and to the point thing about leaf-footed bug. Biology and management of leaf-footed bugs. Okay, so similar kind of outline for this as we did for the navel orangeworm. Talk about origins and distribution of leaf-footed bug in California, their basic biology and seasonal ecology, and then a much more limited suite of practices available for their management. And once again, here's all these other supplementary resources that y'all should use to augment the kind of quick version, quick overview you're getting here of each of these insects. So your local advisor, UC statewide IPM program, then of course the Pistachio Production Manual. Okay, leaf-footed bug. This is a hemipteran pest, pure suck feeder. Kent did a great job outlining all of that. We have 3 species in California: Leptoglossus zonatus, Clipialis, and Occidentalis. Zonatus is the main one you're going to find in your orchards. Clipialis used to be dominant, and it seems to have been displaced by Zonatus. Early reports from the 1900s finding this thing around South America, Central America, Baja California. 1940s, we have reports of it on citrus and pomegranate in Arizona. And then with the development of the pistachio industries in the 1970s, we shortly thereafter had reports of leaf-footed bug attacking pistachios in California in the 1980s. As I said, the Clipialis, that was the species, focal species then. Today, it's mostly Zonatus. All 3 of these have fairly distinguishing characteristics. They're called leaf-footed bugs because they have this flared kind of leaf-looking appendage on their tibia. Leptoglossus zonatus, it has these 2 distinct yellow marks on the pronotum right behind the head. As I said, it's the most common species right now. Clipialis doesn't have the marks, and it has this extended clypeus, kind of looks like a horn coming out of the front of its mouth parts. And then Leptoglossus occidentalis, no marks, no clypeus, rare, rarely found in orchards today. So really, you're going to want to look for just those big spots. That's your leaf-footed bug, Leptoglossus zonatus. Pure suck feeder primarily feeds on seeds. They do attack a wider range of hosts outside of pistachios, and I'll talk about that a little bit more. Similar to the stink bugs, they directly attack the nuts early in the season. That can cause epicarp lesion or nut drop. Later in the season, can lead to kernel necrosis, and some great work by Thamus Michaelitis showing the even once you have the shell hardening, leaf-footed bug can still puncture into the nut through what he termed the Achilles heel. This is this basal part right at the bottom of the stem that's still soft enough for them to pierce through. This feeding, they are kind of dirty. They can introduce different pathogens that can cause a range of issues here listed below. So basic biology and seasonal ecology, they have eggs, of course. From those eggs come nymphs, the immature stage. Those go through 5 different stages or instars, and then they ultimately molt into this adult form with the distinct leaf shape on its legs. The eggs are kind of these laid in strands. I'll just focus a little more on this. They're sort of barrel-shaped, brown. They can be laid, this picture obviously shows it on a pistachio nut, but they can be on leaves, twigs, nuts, but they're distinguished by this form and the color, and that they're kind of in these, or they are in these long strands of multiple eggs. Leaf-footed bug exhibit this unique aggregation behavior, certainly during the winter period, but also in season. You can find them in these large masses. This is on pomegranate later on in the year. So they kind of like to bunch up. They overwinter as adults in sheltered areas. Those sheltered areas can take a variety of forms. We found them overwintering these aggregations in things like wood piles or barns, eucalyptus trees, citrus, things that are evergreen, cypress, juniper, and the list goes on and on. So it's not that there's a specific host plant that they need. It's more of a kind of physical form of place to go hide out during the winter from the elements. So I get a lot of reports of growers. This is that are seeing higher populations, when they in their orchards that are closer to residential areas or riparian areas. Those are both spots that have a lot of potential sites for these aggregations to form. Broadly speaking, their seasonal activity, they tend to sort of move through these different crops as each of the different crops becomes vulnerable. So here's these overwintering aggregations. In the spring, they move out from those in search of feeding and reproduction sites. At that time of year, young almonds are attractive. They're able to be fed upon. And so they show up in almonds first. And then as those harden up, they'll move on to pistachio. As those harden up, they then move on to pomegranate. And then as they finish out the year, going back into these overwintering aggregations. And throughout this period, reproducing. So they have multiple generations per year. Of course, throughout that whole period, they also can feed on weedy vegetation and even other crops. So again, it's not such a strict movement like this across these 3, although these are the 3 primary crops that they attack. They are known to feed on these other things outside of the orchard. In our lab, we've been developing the use of gut content analysis to identify some of those alternate hosts and to understand the extent to which they're utilizing them. So we have a really hardworking grad student at Fresno State, Danny Evans, and she's basically developed a way to do microsurgery on leaf-footed bugs, pull out their gut content, and then run an analysis on the plant DNA that's in there to determine what plants they've been feeding on. And so this is just some preliminary data of hers from last year, but showing leaf-footed bug that were collected in a pistachio versus an almond versus a pomegranate orchard. And then this is showing the relative percentage of DNA in their gut that came from these different hosts. So, here's something from a pomegranate, 68% was pomegranate. Of course, it's doing a lot of feeding in there. Pistachio, 34% was from pistachio. But you see, but the important thing to notice here is that there's all these other hosts, and some of them are agronomic crops, some of them are weeds, some of them are things we find just in the landscape. And there's a lot more to come here. This is just some pilot data, and we're currently in the process of sort of doing a much more elaborate collection of leaf-footed bug across the valley at different times of year and situations. So more on that to come, but just the emphasis being that on one hand, I'm showing you this seasonal movement from almond to pistachio to pomegranate. There's other stuff they feed on, and we're trying to better understand that because we think that does drive their populations and their activity in orchards where they're pests. So this is some data that Kent Dana and I recently put out showing the timing and the number of generations per year of leaf-footed bugs. So you've got egg strands here. You've got these 3 different generations. Here's the nymphs, the immature stages, and then the adults. Just showing that we do have 3 to 4 generations per year and the relative timing of those different life stages over the year. So integrated pest management of leaf-footed bug. You've got biological control, monitoring, and insecticides. Biocontrol, the primary parasitoid that attacks leaf-footed bug is this Gryon pennsylvanicum. It's an egg parasitoid. I've got a graduate student, Rob Strasser at Riverside, who's working on this. It's here. It isn't super specialized on leaf-footed bug. We think it does have an alternate host that it's utilizing. What we see is that it's really most active later on in the growing season. So some data that Kent generated showed that parasitism occurs, but it really ramps up later in the year. That doesn't do anything to control the adults in the spring. Now, parasitizing the eggs can knock back the population so that it's lower going into the following year. But, you know, in terms of managing your orchard in a way to give biocontrol a chance, it's very unreliable at this stage, how to manipulate this parasitoid, how to get kind of maximal activity from them to reduce populations in the orchard. The monitoring program is also somewhat limited. So it's primarily beat sampling of clusters in the tree canopy, along with looking for egg masses and other kind of visual things, looking for signs of damage. You want to start doing this in April. And the beat sampling, you're going to go out earlier in the morning. It's cooler. The bugs are less active. Hold a tray below the cluster, strike it multiple times, see what falls out. If you see nymphs, you know that you have a reproductive population in the orchard. And that's kind of your key to consider potentially treating. Again, there's a little more nuance to it at the UCIPM website, but we really don't have clearly defined economic thresholds for this insect. Obviously, these sampling techniques are fairly labor intensive to move around a large orchard and collect beat samples at the frequency that we need. But there are some ongoing efforts. I'll talk about that at the very end here to develop a better trap. Again, similar to the stink bug chemicals that Kent listed, you're primarily relying on pyrethroids here, just listing some of the main ones that are recommended. As I was saying earlier in the day, anytime you're putting on a spray, you want to make sure that your rig is calibrated, you're doing it under the right weather conditions, you go slow, all that good stuff. In terms of predicting where to see leaf-footed bug in your orchard, you're going to want to consider if you're looking across a spread of different orchards, you want to consider the proximity of them to potential overwintering sites. I mentioned these residential areas and evergreen vegetation or citrus, or even potentially, anything like that could provide shelter. Of course, your previous experience as well in that orchard. Dry down or tillage of adjacent weedy fields. That's another kind of common anecdotal story out here from a number of growers that, you know, the populations really seem to jump after that sort of event occurred adjacent to an orchard. You have these things, they do seem to like to feed on seeds of grasses and things like that, weedy material. And when that stuff is eliminated kind of en masse, that can cause them to shift over to whatever they can find nearby. The key in all of this is that these populations are very fast and sporadic. And so again, it's why we're trying to improve the monitoring tools that are out there for them. But really, I just can't emphasize enough that it's important to be on top of this in the spring, because these things, you might not see them for a while and then kind of boom, they're all there and it's out of control. So you really have to be active about monitoring. Again, all the resources, your farm and IPM advisor, statewide IPM program, and the Pistachio production manual. And that's it. I'll just end on some of the work we've been doing with monitoring, where Kent had mentioned another faculty at Riverside, Jocelyn Miller, who's been working to characterize and synthesize the pheromone of leaf-footed bug. We've made a lot of progress on that, thanks to funding in part from the Pistachio Research Board. And we're at a stage where we have the complete blend. We're still in the process of actually synthesizing and making lures that we could use. In parallel, we've identified a certain trap type that seems to work well for capturing leaf-footed bugs. So the goal is to pair that trap with this lure so that we can have a passive monitoring system that doesn't require you to walk around the orchard doing all this tree canopy sampling. But don't really want to get too far into that today because we haven't fully developed the system. But all I can say at this point is we've made a lot of progress on it and are hoping to have something in the future to improve that. So with that, just thanks again. Always happy to talk here, and feel free to ask me any questions or email. Thanks.
All right. Thank you so much, Houston.
And if you could just address the poll, and then we'll move to questions.
Sure. Okay. So leaf-footed bug can feed on many hosts. Which orchard crops do they primarily attack? The answer is all of the above. So almond, pistachio, and pomegranate. Again, there's other things they do feed on, but these are the three primary orchard crops that they attack. Most of y'all got that right. And then what part of the tree do leaf-footed bug feed on? They directly attack the nuts. So not the other parts of the plant listed here. Okay.
All right.
Good job, everybody.
Okay, so the first question is actually for Kelly. Can you go over again briefly how people are going to access the quiz and how they're going to get their certificate?
Yes, and actually I will put this up real quick and go over that so that people that need to leave can.
Okay.
Do you see the PowerPoint?
Yes.
Okay, so by the end of today, so don't email ANR program support until 5 o'clock today. If you don't get an email in your inbox before 5 o'clock today, you want to email us, but you'll get a link to a quiz. And you have to take that quiz within 1 week of today. So by next Wednesday, you have to take that exam and pass with 70%. It will, regardless of whether or not you want the credit, you're going to get an email today. Anybody who is registered will get an email. You can ignore it if you don't want the credit. For CCA, you can scan that code right now that's up there. Just open the app and scan it. Again, and then once you take the exam for DPR, you'll get a certificate. It will be mailed to you once you pass. But again, give us about a couple days to process it. So if you don't hear by the due date next Wednesday, that's when you can follow up. And that's it. I'll leave this up while you guys go ahead and answer the questions.
Great. So the first question is for Kent. Do you have any information or data on what the best seed mix for cover crops and pistachios for beneficial mite management is? You're muted right now, Kent.
I'm muted because I don't have a good answer for that. No, that's what Judith Stahl is a postdoc in the lab working with Houston and myself, and that's what she's trying to find right now.
Okay.
The main issue that we found, we looked at ground covers about 15 years ago, and we tried a variety of different materials, from vetches to clovers to mustards. In most orchards that have got a drip line system on the berm, the worry with the ground cover that's been seeded is that it can build up both pests and beneficial insects in the orchard. And when it's allowed to dry down, because you're no longer irrigating the middles, some of those bugs can go up into the canopy that really don't want to. So the trial we're doing the last few years with Judith and our cooperating growers, the Nichols, they've got the drip line in the middle of the row, keeping the ground cover green, throughout the season. And that's keeping the different species of ground cover mixes we've got attractive to the stink bugs and small bugs, keeping them out of the canopy. That's the hope. So has less to do with what species we're working with and more to do with those things drying down and allowing the material inside them to go into the canopy.
Okay. So this next question is for either Kent or Houston. Are there any non-pyrethroid control methods in the pipeline or that you're interested in?
We've been playing with some materials, but I think Chris Tollerp is the one that's been looking at different insecticides for leaf-footed bug. I understand from discussions with him that he thought belay was one product that might have some potential. I think it's work that should be continued though as well. Of course, we used to use lanate and lorsban. We can't do that anymore. Those were great materials as a knockdown in the spring. And we went over to the pyrethroids. The issue is that the systemics don't work that well because you're getting these migratory populations, especially of the leaf-footed bug, that will come in and feed directly on the crop itself, feed very quickly. And so you need a material that is very fast acting. And that's typically what the broad spectrums are. They're contact materials. Houston, do you have anything to add to that?
No, that's more of an answer than I would even give. Yeah, I don't see anything in the pipeline. I think Chris's work was looking at that, but there's nothing to my knowledge. It's like new and exciting or anything.
Mm-hmm.
So I think this next one can be directed to either one of you. So what can we do to help our growers with activity in Golden Hills where there does not seem to be any external damage?
Houston,
that's for monitoring where you're trying to use that as a way to gauge whether or not they're there. I assume that's what they're asking. I mean, you have to do the canopy sampling to see if the bugs are there. I mean, there's really not much else available, which is a big bummer. Like that's why we're trying to work on a better trap so that you're not just going on, even when you can see the damage, it's an after the fact sign, and you obviously want to catch them before that happens. So I would just recommend being really aggressive about the, sweep net sampling the ground covers, beat sampling the tree canopy to catch those things as soon as they show up in the orchard.
And I'll add that if you remember, I had the 2 slides that showed sometime after late June, we were not seeing epicarp lesions very much at all anymore. And that started with a guy named Ogawa out of, I think he was Thamus's mentor, out of Davis, that showed the skin of the pistachio starts to change. And so you can poke it and not get an epicarp lesion. So that's what I was pointing out. We were getting in cage studies feeding damage, kernel necrosis, that was showing up in July and August. We were not seeing epicarp lesion. We were seeing a hole poked into the nut, but the outside skin was not turning dark, wasn't showing that epicarp lesion. And that's why the monitoring of damage is good in April, May, and early June. But once crop load has set, we don't get as much of that epicarp lesion damage.
Last question. This person gets leaf-footed bug pretty bad every single year. This person feels that they're always responding to them in a reactionary manner. And so they're asking if they should just carpet bomb when the almonds are green. And again, when the pistachios are in the BB stage. So they're just asking basically how to control them in an orchard that gets really bad infestations.
Yeah, I would not preemptively, I would not recommend preemptive treatments like that. You just got to be on top of the monitoring and try to be, ready as soon as you see them there. I know that's a tough situation, but it sounds like you're doing all the right stuff. Just monitor very aggressively when they see them, make the application. And if you know that you're getting hit every year in the same spot, then again, still monitor before you do anything. But yeah, I would keep more of an eye on that block.
That was the whole point of my talk, is that we have to try to monitor for these things, but I'm not a grower. Pyrethroids are cheap, so I kind of get it. But
Yeah, I know, for sure.
you're gonna do it. You're gonna get resistance to pyrethroids if you keep spraying. So we want to monitor and spray when needed, if possible.
All right. There's a last question. Would you recommend spraying twice in season for stink bugs?
Boy, you know, it all depends. It depends on every individual orchard, because it's very, very feasible. I could easily see getting a lot of the Chinavilla, which is our classic green stink bug, early in the season, because that does overwinter. I could then see getting a lot of Chlorocroa, especially on the west side, coming in as they like Russian thistle. We saw a lot of Thyanton Russian thistle. I like with Houston, you've seen leaf-footed bug come in later. So I could see, even if you did a fantastic job monitoring, getting a lot of one species early in the season, and then getting a second wave coming in late in the season of a different species. And that could require 2 sprays for stink bugs per year.
I see, Thamus, you flagged this. Did you want to respond to it at all?
He's going to tell me that Ogawa was his tormentor, as Louis suggested.
I should not comment on that. He was a good professor during when I was a student, but when I got this job, we became competitors in a way. But yeah, the study with epicarp lesion and the kernel necrosis was done by Rick Bostock and Carla Thomas, a postdoc working in his lab. He's a plant pathology and physiology.
If anyone wants, email me. I can send them the citation and the publication. It has to do with the oxidation of paradox or something like that. So
Exactly, yes.
cool, thanks.
One other thing for the leaf-litter bag, because I was involved in initial research with this, with Dick Rice, and I have a pistachio tree in my backyard, and I get 100% damage by leaf-litter bags. So does any of you consider what is going on in the backyards of people who have pomegranates, pistachios, and you know, they show very early, and I cannot harvest any pistachio. It's really very big damage and a lot of leaf-litter bags.
Yeah, it's density, Thamus. You've got too many leaf-litter bugs near you.
Hey, you got a carpet bomb, Thamus. No, I mean, they eat up my garden too all the time in Fresno, and urban areas, I think, provide a lot of habitat and I think a lot of shelter for them to overwinter in. And that actually was part of our gut content analysis work. We're going to shift it or expand it into urban areas as well, just to see what those differences look like. But, you know, and people aren't being that aggressive in a garden, right? I mean, I've
Of course, yeah.
watched them kill my sunflowers and tomatoes every year. It's just kind of a part of the deal. So yeah, I don't know what to tell you, Thamus, but.
Okay.
All right.
Okay. Well, I guess the last one is a comment: carpet bombing prevails. Okay. Well, thank you everyone who spoke. And we will be meeting again on Thursday. And I do believe there are DPR credits offered that day as well as regular CCA credits.
Thank you.
Okay. Thanks, everyone.
Thank you.